Song is a banger. Song is a banger, and I don't care. Oh. Okay, so what's happening here? That's a good question. You are first. Hello. You're very first. I didn't even put the link in the Discord yet. Wow. That's so early. Okay, so last night I implemented Flow Lenia in 3D, which is something that I never thought that I would get done. Which, it probably, you don't know what it is, so it's all of this. And so doing it in 3D was definitely not something that I thought that I would be able to accomplish, but I did it. And I fixed the bug last night that I had during stream. I figured it out after I got off stream. I couldn't sleep, which is why I'm very sleep deprived right now. But I'll show what the bug was. The bug was simply that this was a Y. That was the bug. So yeah, it was just me being very, very stupid. I also looked back at my code and then I realized that this is necessary because all of these separable directions can and will go into the negative and then wrap around, which is not what you want when you're convolving. So anyway, so yeah. Yeah. Yo, what's up, Lane? Oh my god, Lane is on my stream. That's crazy. Hey, what's up, Robert? Robert cannot? Robert, more like Robert will. Anyway, my birthday is about to come up. I was talking to my sister, because she was going to a birthday party and we were yapping, blah, blah, blah. And I said, man, I'm getting old, because I realized, what age I was turning. And usually when I say that, somebody's like, they say like, oh, you're not getting old. But my sister was like, yeah, you are. And I just thought that was so funny. But man, I really am getting old. It's like I'm on the other side, like when you're a kid and you just always think like, man, I'm never going to get old. You really do believe that shit, like inside, like you kind of are like, I'm never going to be on the other side, but now I'm on the other side all of a sudden, or I'm like in the second half, I'm in the I'm in the second half of the race, and my legs are getting tired, anyway, so all of this stuff is incredibly expensive, what we calculate to do the Flow Lenia stuff with the mass reintegration and shit. So I think I should change my username. I mean, feel free, if that's what you want to do. I think it's time to do some cleaning. So that's what today is going to be, because we have a lot of buffers. Since we did the mass reintegration stuff, we've added all the buffers down here. H is the sum per channel. Sum is the sum across all channels. Nabla A is the Sobel convolution across all channels. Nabla U is the Sobel convolution per channel. And then F is F and MU are inside of one buffer because they can be reused. And F is, I forget. It's the, you're interpolating between Nabla U and Nabla A per channel. And then that gets transformed into MU later. I forget what MU is. But anyway, MUR is the big one that we convolve into. That's our full kind of mass reintegration, where we basically have moved our mass and now we are displacing it in a ball around itself, which is a very complicated and expensive calculation that I hope to streamline eventually. my goal here is to take a look at what we're doing with the reintegration step and make it a bit better, because right now it's very expensive. The roll that we do is insanely expensive. As you can see, we go per channel over the entire span of the grid, right? And we do that for the entire DD row size per channel. No. We do it for each DD roll size. We roll over the entire grid, which is incredibly expensive. And it's why flow Lenia is difficult to do in 2D, let alone 3D. So it's possible that we can approximate this. Anyway, what does it look like, Dustmite? Well, I'll show you what it looks like. Yeah, so it looks like this. It's pretty sick. It is pretty laggy, but as you can see, we are a lot smoother now in terms of the formations that are starting to happen. We have a cell wall right on the exterior of the volume, and inside you can't really see because of the wall, but we have a lot of cool things going on. And we can try and traverse the space right now to try and get some cooler shapes going on. You know, if it was 60 FPS, it would be absolutely rad. But we aren't going to get it to 60 FPS. But now you're starting to see how this becomes a proper cellular simulation, especially when we get into the reintegration, right? So what's happening, you see this bubbling up that's happening with all of the walls and everything. The mass is literally getting redistributed every frame in a proper manner, and so that's what we're seeing. But of course, it isn't the most efficient thing of all time, but it is nonetheless really fucking cool. I mean, not to like, you know, pat myself on the back too much, but I think it's just one of the coolest things I've ever made. So I'm very excited about it, and we made it in a week. So anyway, it's incredibly fun to just play with. It's incredibly fun to just play with. But yeah, the idea is to make it more efficient now, so that we can get it to be less laggy. Because I think when it's less laggy, it's a lot more fun. Like, this is a single channel. Yeah, it looks faster. It is faster. It's not only faster, it's just the mass reintegration that we did makes it look like real mass, right? As far as I know, nobody's done that specifically in 3D. Because it's incredibly expensive and difficult, but we managed it. But I think we still need to streamline it to the point where, like, obviously we start lagging when we have multiple channels, like this one is red and green. So we start lagging here. But yeah. I did spend, like, last night, like, maybe like 2 hours just pressing the R button and seeing what it could make. It makes some wild stuff sometimes. I'm trying to get to a more stable thing. Doing Conway? It's not Conway at this point. It's definitely not Conway. It's Conway with, you know, with Sobel convolution in X, Y, and Z separable. You know, it's definitely not Conway. But I mean, loosely, very loosely Conway. Still looks like it's I don't know about that. Yeah, the mass reintegration stuff really helps because as you can see, the mass starts jiggling and moving in a really natural way. Yeah, so that's what I was saying, is that one channel looks really smooth, but with multiple channels it quickly becomes chaotic. Yeah, it's so fucking sick, man. Anyway, so what am I doing today? I'm changing to destructive arrays. Which all the zoomers are gonna love. I'm just kidding. But, you know, all the optimization people are going to love it. I tend to not optimize early, but I think in this case, I have done the entire formula in the simulation. How's progress? It's good. So last night I implemented mass reintegration flow Lenia, which was not easy, but luckily I had already programmed it in 2D and C, and so all I had to do was transfer it to 3D. Wasn't necessarily easy because we had to do Sobel convolution in 3D, which, believe it or not, isn't a thing that happens because it's mainly used in photos, but nonetheless I did it, and that's what it looks like. We have a lot of like naturally moving mass now, whereas before it just kind of moved around. Now it's well, it's a literal physics simulation beyond just like particle velocity or whatever that, you know, most physics simulations are. This is us doing a lot of calculus. So that thing I was trying to implement last stream, the FFTW threading compilation? No, I gave up on that. Narco trafficking? Yeah, I hope that you were all right. You were pretty smashed, bro. Don't be ashamed or anything. Like it was hilarious, but I hope that you're all right. You did say at some point, I'm gonna yak. So I hope that you ended up okay. No, it's okay. I don't care. I don't care. It's just, you know, my you should you know, stay away from that stuff, man. I said yak, like throw up. I don't want to say throw up. Yak, man. You've never heard of that? I'm gonna yak? Maybe that's a New York thing. That's what we used to say. Yeah, it is pretty volatile sometimes. Like this, but this is... You're good, it's a one-time thing, yeah. That's chill. Yeah, it is pretty volatile, but that's just the nature of flow linear. Like when it gets like this, that's kind of normal when you're traversing the space. Anyway, yo, what's up, Deepin? So we're going to structural arrays. You know, the CPU heads are gonna love it. Oh my god, cacheways! Oh my god, the fucking cache, the cache. Alright, let's optimize. Because we need to make this thing a lot faster so that it stops lagging. And the only way to do that is to make all of these arrays vectorizable. Look at me. Maybe it's a sign of my age that I'm now doing this bullshit. Young me would have never done this. Okay. Okay, so we want to call this a cell, because it's a cell in our simulation. And a cell in our simulation is going to have all of those things. So here's something I wonder. So this is a struct for a vec3. Would it be, is it more efficient? Can you process made that CP? Yeah. Is it more efficient to do nabla A to 3, right? Or is it more efficient to do nabla A vec3? Or is it going to compile the exact same? I feel like it's probably going to compile the exact same, right? So this would look like grid size, right? No. Okay, so this is the dilemma I was having, right? Is we have 2 dimensions, right? So it doesn't look like it, right? So this pointer, this actually is max channels grid size, right? And so I'm trying to figure out, because I looked up SOA and I tried to look up some example code, but none of them have it with this many dimensions, right? So I don't know which one I'm supposed to put in here. If I'm supposed to go for each channel and then go cells to grid size, or if I'm supposed to go max channels grid size like this. No one was telling me the answer, so I genuinely have no fucking clue. I think it depends on what I'm doing with it. But I'm kind of too dumb to like think critically about what I'm doing with it, because I do a lot with it. Think grid side then max channels. Yeah, that's what I was saying. It was saying max channels in here, and then grid size here. That's what it was saying. Because then it has to, apparently it has to load less into cache if you do it this way. That's the way that I read. Like, I read that like if I did it, when you write this, right, you're basically loading all of this into cache, everything inside of it. And so that's why you want to put the channels inside, so that you're loading only the relevant stuff into cache, and then you process all the channels at once in parallel. So yeah, you iterate this inside and you just do it per channel, and then you just have to load less into cache that way. But I have no clue if that's true. I'm just kind of repeating what I've heard, and typically what I hear is bad because people suck, but whatever. Okay, so let me try. I need to figure out how I can align this at boundaries. So, okay. So it said 16. Is it 16-bit boundaries that I need to align to? Aligning struct boundaries for vectorization. Struct align as 32. I've never done that before. Okay. This is really a thing? I've never done this. That's a thing? I'm sorry, I'm the guy streaming, right? I should know. What am I building? I'm building a cellular simulation in 3D. It's really only been done in 2D Flow Lenia. But, okay, so it's not going to let me compile, but you're just going to have to trust me. Wait, so this align as is correct, right? Okay, so if I have 3 floats, we got to do some math here. That's 16. Wait, no, that's not 16, you fucking idiot. That's 12. Yo, what's up, Saz? This is 32 bits or 32? This is 32 bytes. 100%. Yeah, that's bytes. So I've got 12 here. We got 12. Oh, fuck, this is gonna get complicated. This is gonna get complicated. Hold on. So if we have complex, let's call it val for max channels. Okay, so let's lock the fuck in. Okay, we might actually have to do math here. Like in terms of like, okay, because this is 2 floats times max channels, which max channels is how much? 6. So that's 2 times 6 times 4. So that's 12 times 4. That's going to be 48. Okay, but that's not all. This is, that's 16 extra. So we're 16 off to go into to roll into the next one. This is not linear algebra. This is like preschool math, but it's hard. Okay, so this is the back buffer. So now we were at 16. Wait, but this isn't aligned though. This is the definition of not aligned, actually. Wait, but how do you align that then? Do you need to align as 64? Is that what you need to do? Fuck. I need 32 is the problem. I need 32 because of the CPU. So maybe this will just work. Maybe I don't have to do the math. Maybe it'll just do it for me. I don't know. I've never fucking done this before. What? Do you think I've done this before? Okay, do I actually need this temp buffer in here? Yeah, I probably do. Okay. I'm sure that we're going to undo this eventually, but this is gonna get complicated, man. Okay, so I'm just gonna put everything inside of here and just pray that it's fine. I have no clue how to like align these properly, but I'm just going to assume that me writing a line as is gonna take care of everything for me. It would have been pain if it was Java. Well, yeah, but what timeline would I be coding Java right now? Okay, so this isn't gonna compile, so maybe a none, yeah. Okay. So here's the problem with what I'm doing here is that now we can't actually memset a single array in here, which doesn't sound like a bad idea. It doesn't sound like a bad thing, but it is a bad thing, okay? Because we can't memset a single array now since it's all structive arrays, which means that if we want to set something to 0, it's going to be way more painful, and we do need to set something to 0, so yeah, we might have to have like another buffer just for that, which it sucks, don't get me wrong. Where's this grid width and grid height? Okay, so I think it allows me to do this, right? I can do this, grid size. It allows me to do this. It does, right? No? Don't tell me I have to make this like a const, bro. Bro, that should be... Bro, you can totally get that at compile time. Okay, no, it's fine, it's fine. Okay. So this is going to be our array to grid size, is going to be all of this shit. I wonder how many bytes this is, in general. Like, we can estimate it right now. So if these are all 48... That's a lot of bytes, brother. That's a lot of bytes, because these are 3 floats. I think it's necessary, though. I can't really reuse a lot of these. I probably could reuse... I already do reuse T, actually. For the last step, I think. Yeah, I reuse T down here when we sum. So... I can't touch back, apparently. I can't remember the reason, but yeah. Okay, so let's comment all of this out and then get to work, I guess. I have no clue if this is correct. I kind of wish there was one of these guys that would, like, you know, always telling me to do structural arrays. We're here right now to be like, oh yeah, you're totally doing that right, or whatever. Like, where are they now? Huh? Everybody's always telling me, go structural arrays, but now that I'm doing it, nobody's here to tell me if I'm doing it right. So, I'm just gonna assume that I am. We're gonna pray. We're gonna hope and pray. Okay. So now that's all in here. Okay. We do need to memset it once, at least, right? So we just are gonna memset it here. We're gonna have like an insane amount of problems here. Like this is gonna be an insane refactor. But, yeah. Can I just do size of cells? Yeah, I know, music. Oh. Oh, my thing was lagging. Okay. Okay, so that's 2, 4, 5, 7, 6. And by the way, us doing it this way means that we can't reallocate it during runtime. We can think about that later, but I have no clue how I'm gonna fucking align that if we do that during runtime. Okay, so... I guess we have to just, like, walk through it step by step. So let's actually start on the rendering side, because that kind of makes the most sense because it's the easiest. So instead of going per channel, we want to go per channel on the interior of the loop now. Which is going to change some things. Yeah. Oh, this refactor is going to be painful. I love coding on this machine, but what I don't like is refactoring on this machine because it is truly painful. Okay, so the thing is... Okay, no, this is fine because we're going to step through all of them at the same point. Okay, so I think I just literally have to put it here. I think it's literally just there. Because apparently this is better to load this into cache than the other way around. Apparently. Okay, so this is going to be cells, grid, index, mid, dot. Why is this an integer? What? Did I make it an integer? No, I didn't. Why is this an integer? Okay. Okay, so apparently you can't do that, whatever I'm doing here. Apparently that's not a thing that you can do. Or maybe that is in like a new version of C++ that I'm not on because I'm on fucking Apparently there's also attribute. They write it like that. Okay. Okay, well, we'll find out if it works later. What's the font's name? It's a fixed SYS. Fixed SYS on Windows 32. Windows 32, Windows XP. I'm thinking about 32 bytes right now, sorry. Okay, so this is .val C 0. Yeah. Yeah, I see why people don't shoot structure arrays. Like, what is this, bro? What is that? I hope that I'm doing this right and I'm not doing this backwards because, like, I looked at the Wikipedia page and it looks like this would be here and then this would be there. But I don't know. Whatever. If I have to refactor this again because of that, I'm gonna be pissed. I could probably also make this more efficient, but we won't worry about that for now. This doesn't need to get cast to a float, of course. I could definitely make this code more efficient. I kind of just wrote it kind of quick and dirty. So I'm not going to sweat it too much though. I'm just going to keep commenting things out just in case I have to revert it later, since this is going to be like a big refactor. So, yeah. Honestly, we should just... Oh no, we're looking them up here. So then let's just cache the value. So let's just cache the value here, and so that we don't have to keep looking it up in the table. Micro optimizations help, apparently. Or maybe the compiler just optimizes it away anyway, but people keep on telling me to do things like that, so whatever. Okay, apparently I don't check cells down here, which I think is weird, but I think that I'm thinking about when I was doing central differences, so I think it's fine. Okay, so that's the rendering stuff. All of this stuff, actually, we can't actually do this because those aren't even separated arrays anymore. So yeah, neither of these. I know it's ugly to comment all this stuff out, but I just need to keep it there for, you know, today. Okay. All of this stuff can say. Okay, so we're fine to go to the simulation step now. I wonder if we want to make this also even more efficient here with the kernels, and just make the kernels also not mallocked. I'm also kind of worried about like FFTWF malloc. Like, we're not mallocing these anymore, so I wonder if like it's gonna get mad at us because of that. I'm not really sure. I've never not mallocked the FFTW stuff, so yeah. Let me see where the kernel is. Let's just put it up there. We can totally just like avoid allocating it completely for the same purposes of aligning it to optimize this. Yeah. Okay, let's do that. So I think the only time we touch that is when we initialize our kernel. Right here. And so when we initialize our kernel, all we want to do now is just memset it. Like this. That's all we need to do. And we can use grid size now. Once again, I'm not sure. I'm pretty sure that the compiler just obviously is going to optimize that away. But just for the peace of mind, I guess, you know, somebody yesterday was like, oh, I should do that. And I was just like, I'm not doing that. But it's like, whatever. Like, we just need to be sure, I guess. Okay, so now we aren't allocating anything. Yeah. Okay. This convolve function doesn't even exist anymore. Oh, we can... Dude, this is the awesome thing about working in a goddamn IDE, is that you can do this, by the way. Like, it's so insane that text editors don't have that yet. I mean, maybe NeoVim does have a plugin for that, but Helix doesn't. Or maybe they do. I haven't, like... I don't really use any of the tree sitter things, but... I just think I don't even use that just instinctually now, but that's such a neat thing. I think this is ugly, whatever this is. I hate that, but... Yeah. I feel like that... Honestly, like, I'm like halfway done with my text editor. I should just implement that myself. It probably isn't that difficult at all. Definitely, you know, the same amount of complexity as copying and pasting. So, just need a place to store the buffer, and that's it. Okay. So convolve FFT, this is just the complex multiplication stuff, right? Yeah. So temp buffer, once again, is on our cells. It cells I.temp. Yeah. So the cool thing here, right, is that, as you can see with what I'm doing here, is that all of these, if you can think about it this way, like, when we're looping through, everything now lives in the exact same place in memory. So that's like the whole point of this. But I don't typically do it because it greatly... It makes the code really hard to change later, right? Okay, so this is obviously going to be cells dot. Wait a second. Oh shit. JetBrains mono, yeah, I can't stand the modern fonts. Oh my god, man. Wait a second, I can't actually do this. I can't actually do this. Oh, fuck. Or this needs to be a separate struct that goes in the other direction. Oh, but then that throws everything off. Fuck. So what I'm realizing now, by the way, is that if I want to FFT, this needs to be at a grid size, right? Because it needs this contiguous. Shit. Okay, so we need to like think. Okay, so it's technically possible for me to have this stuff indexed the other way and then this stuff indexed this way. But I don't know if that would defeat the whole purpose of having it indexed this way. You know what I mean? Like, how would the indexing change? Oh shit. Yeah, the thing is you can't do this stuff struct of arrays. Or you can, but it has to be grid size. And then that defeats the whole purpose, because then you need to have something like a second struct to max channels. And then have this stuff to grid size. That's difficult. Yeah, you need... Oh my god. Yeah, I knew that this was going to be more complicated than I thought. Fuck. Or we could just give up and do everything to grid size inside of here, and just have it max channels on the outside. Fuck. What edition? This is professional. You know, like they do in those shows where they're like the trivia shows or whatever, like Who Wants to Be a Millionaire or whatever, where they're like, I want to phone a friend. I want to phone a friend right now. Can I phone a friend? Oh my god. How do the professional programmers handle a problem like this? Where you have this stuff that needs to be max channels, and you have this stuff that needs to be grid size to FFT. Like this needs to be indexed like this, but for better cache stuff, we need it like this for this data. And I'm assuming that if we have both of these, it's going to just defeat the purpose when they overlap. Because it's just going to fuck the cache up. You know, it's not going to know what to load. So I have no clue what to do. Oh man, that's messed up. Yeah. I had a feeling that that was going to be complicated. Okay, so let's actually think here. So the whole idea was to load in the channels inside of here into cache, right? And so the idea is to do the channels basically like in parallel inside of here, because then you're loading less data into cache every time, right? But you can't do that. Professional programmers are dead, now it's just AI writing code for them. Yeah, you should have seen what I put in the Discord. Or maybe you did. I don't know, I was really thinking about that the other day. Like, this is actually like a Wall-E type of situation that we're in. Where like, art and craftsmanship are just going to die. And like, humans are going to be useless. You know? It's just sad to see. Like, I think AI can be used well. Like, even I use LLM sometimes when I need to, like, talk through ideas or whatever. But the fact that they're used to, like, straight up replace programmers... Like, I've never used anything like Claude Code or Codex or any of this shit where it, like, writes the code for you. Like, that to me is, like just mind-blowing how that's, like, a normal thing that people are doing nowadays. Like, do you not want to actually code? Like, and all these companies are like, oh, our engineers do less boilerplate now. Like, what the fuck is a boilerplate? Like, really? like, like, dude, that's called programming. Like, what do you mean? That's called programming. What's up, Mano? It's so interesting. I hear this argument about like, oh, AI is saving our engineers from doing boilerplate. It's like, oh, you mean you're just laying people off? My first experience with vibe coding sent my code base to hell. Yeah, I mean, I've never tried it because it's like, first of all, you have to pay for it, at least with the other ones, but like, I don't know. Like, it's just crazy to me. Like, I take so much joy in making something. Like, I got into programming because I liked programming, not like making money from it, or like, not like because I like the idea of programming or whatever. Like, I just like programming. So just like seeing it, but tools like Copilot, yeah, I mean, I agree with this to a degree. Also, like, when I was in VS Code, like, Copilot does help sometimes, but it also like sometimes just like doesn't give good information. But I could definitely see that. But I mean, Copilot, I feel like, is different than like Claude Code or Codex or any of those tools that like straight up, like, you give it like a prompt and then it just makes the thing for you. Like, that to me is a bit different. I would like to phone a friend, though. Yeah, the FFTWF complex stuff needing to be in a different way is kind of difficult. Because, I mean, so the thing is, right? Like, at the end of the day, what we're trying to optimize is really the stuff that with the mass reintegration, which is all of this anyway. But the thing is, it reads from here. Like, the problem is, here's what the problem is, right? Is that down here, when we roll, for example, if we want to move this inside of here so that we can iterate it the other way, we want to move it into here so that we can do all of the channels in one cache line. The issue is that this, since it's an FFTW complex, cannot be iterated that way. Because of the data layout, it has to be grid last and not cell last, and not channel last. I used to copy examples from books and use it as my code. I mean, yeah, we've all been there, right? Like, for sure. Like, I don't know. Like, when I started programming, I'm not gonna like say like that my code was like 100% original, because that's like impossible. Like, that would just be a lie. I think like everybody can relate to that. I can't think of like a single person who just like didn't just like copy code to understand how it worked the first time, you know? But do I think that those tools should be replacing people's jobs? Abso-fucking-lutely not. Abso-fucking-lutely not. Man, this sucks. Yeah, I think what I'm gonna do is I'm just gonna go I'm just gonna go for it this way, with having them indexed differently, even though it's really confusing. I have a feeling it's going to still be faster. Because at the very least, right, this stuff, the Sobel convolution that's happening with these... Oh, by the way, this is not max channels. The Sobel convolution that's happening here, this will be indexed the same, at the very least. So, it's not completely lost, I guess, but it is certainly annoying that we have to have them separately, and also that it may backfire on us. But really, I don't actually know unless I write the code. I'm just kind of too dumb to know. So all right, so let's figure this out. Where do I mem set it to 0? Okay. So I need to mem set the cell FFT. Let's actually not call it that. That's just like bad naming convention. But I don't mean to like demonize people who like use that technology or whatever. Like, I want to make that clear. But I don't think people realize how that technology is going to be used by rich people, right? Like, every time new technology comes out, you gotta like think like critically about like how people in power are going to use this technology to take advantage of people that are less fortunate, right? And that technology is 100% going to leave millions and millions and millions and millions and millions of people without jobs. So, yeah. It's like, it's not cool. But yeah, I mean, I think that the technology is amazing, though. Like, all the like the neural net stuff and all like the machine learning stuff. I've done a lot of the machine learning in Atom and all of that stuff. You can watch my chess engine video. I literally implement Atom W from scratch, you know, because I think that stuff is like super interesting. But at the end of the day, I'm like more concerned about the ethics, you know. I think it's how this corporate don't know how to use it. Yeah, I mean, it's not just that they don't know how to use it, they just, you know, they don't have good intentions with it. How's Lenia going? It's going good. I can't really show it off right now, because I'm in the middle of doing a big refactor. I don't know if you can rewind the stream to the beginning, but I have implemented Flow Lenia, which is a version with mass conservation, reintegration. Yeah. Oh, the problem with this is that now this isn't per channel. Oh. I guess we'll just leave it on the first. Right now, what I'm trying to do, by the way, for people that don't know, I'm trying to restructure my code into structive arrays. But the issue is that because of fast Fourier transform, I need my data for this FFTW complex to be in grid size, and then this stuff for more efficient cache ways, I need it to be for max channels. So both of these are indexed in the opposite fashion. Why did your message get deleted? I read it. It wasn't bad. I didn't delete it. I love torturing myself. It's the only thing that makes me happy. Yeah, I wonder if we just want to pass the pointer in anyway. Because the thing is, this lives in a different point of memory anyway. Shit. Yeah, I mean, none of this is very efficient structured arrays stuff, but I mean, I literally have no... I have no choice with it. The thing is, so this convolve FFT only needs to happen on certain channels, so we can't even do it per channel. Oh, yeah, we can. We just... Okay, so this is... Yeah, so let's just do some complicated ass project. I mean, yeah, I mean, like, I don't know. I'm in a world where I love programming, but I don't think anybody loves programming anymore, and nobody is doing fun programming anymore. So I was like, you know, I'm kind of in a position to be like, fuck it, I'm just gonna make my own, you know, programming challenges, you know? So let's just do this. And then the good thing about doing this way is that, yeah, so this is going to be I. Yeah. Yeah, I know what I'm doing. And now we just have to... Oh, we can have a temp buffer per channel. Yes. So this is what I was talking about earlier. So we are loading only what's necessary. Palantir? Oh, you got me fucked up, man. If I got arrested and they were like, oh yes, your punishment is that you have to serve Palantir for the rest of your life, I would, well, I would disagree to do that. I'm not allowed, as per the as per YouTube guidelines, to say what I would do, but I would not be very happy about that situation. Okay. Hey, this is what the cool CPU kids sleep 0 days over. Yeah. So now we put everything into temp. Technically this is less memory efficient, but it should be faster. Technically. Right, because we're loading only, all of this stuff is contiguous in memory, right? And we're loading it into cache. And then we just, you know. Oh. But then you have to do... Oh, but now it's kernel C1, C0, C1. What's the fucking... Is it C1 or C0? C1 doesn't equal C. This is branch prediction, right? Like, this is fine, right? This is fine, right? This is why I hate doing this shit, because it's like... So for each channel, for each kernel, wait, so this isn't for each channel. This is just for one channel. if we were to do this, we would have to loop the kernel as well over each channel. Like, this is cursed, right? But is this what you're supposed to do? If you want to do this all in one step? Fresh engineering graduates think the same until Lockheed Martin offers them 6. Yeah, I mean, I genuinely think with the life that I've lived, I just don't think that money is ever going to make me happy. I think I'm kind of like more like a rock and roll guy than a fresh engineering grad. It is quite a world we live in, though, isn't it? So I know that this looks cursed, that it's this nested, but this seems cursed. But this does all of it at once. Like, you would just basically do this in one step. What is Carp Max? Like, Magikarp? From fucking Pokemon? Ian, do you know anything about structural arrays? Like, you probably do, right? Alex Carp is the Palantir guy? Oh, you're telling me that he actually got hired at Palantir? Dude, I would fucking... I can't say it on YouTube, but I would do some not nice thing. All I know is that they got a raise in them. Yeah. So basically what the problem that I have, right, is that I have these arrays which need to be in this order for FFTs. Okay, so it needs to be to grid size. But then I heard that this stuff is better for cacheways if I do it to max channels. So now I have two different indexing. No, we just interned at some defense company. Yeah. I would not do that shit. All of this looks cursed. Everybody's always telling me to go structural arrays, but then I would go structural arrays and now none of those people are here to be like, you know, no, this is how you do it about the thing. So this growth step, I think I also have to do separately, no? Yeah. But the good thing, actually, this is perfect. Because now we just have to go in a loop and do this. Compute growth. Yeah. And now we just loop through all of the channels. The kernel... Oh shit. Wait a second. Wait, maybe I can't do this way. Because this needs to happen per... Oh wait, no. I can tell you're doing that for the love of the game on some medieval monk shit. Oh yeah, that's true. Oh, okay, so this does need to happen per kernel. I hate when I try to outsmart my own code. Like, who the fuck do I think I am? So this actually needs to be wrapped per kernel. Because the U needs, the growth for the U is dependent on kernel. Yeah, I try to optimize shit and then it always ends up fucking messing me up, man. Yeah. I'm just gonna get rid of the inner loop and just do that this way. I don't know. Also, I don't even think that I can iterate this way. It's not efficient because this is indexed this way. I think I have to do it the other way. Since yeah, so basically what you have to do is you have to do this, right? Per channel that it touches. Execute the DFT for those channels. And then do the growth step right after it. For the entire grid size. Which is already in the opposite convention as this. So, I guess, like, fuck me, I guess. I don't know. Okay, we're just gonna do it the other way. We're gonna, like, yeah, fuck this. Yeah, fuck this. Okay. I don't know why I always think that things are gonna be easier than they end up being. Like, I should learn by now that that's not the case ever. What would I think that good beginner projects are? I don't know. Something that isn't like a fucking weather app or a to-do app or whatever. You know, like make something cool. You're learning C#? Yeah, I mean, well, whatever you're into, man. Like, if you're into like games or like old games or something, like make a game or, you know. Like, if you're into, like, music, try all that, try FFTing and, like, doing that frequency shit. I don't know. Vibe coded to do app. That's the starter project that they're trying to get you to believe is the way to go. Okay. So now we just have to do that in there. Yeah. And we'll just keep it all inline because there's really no reason to not to have it separate. So now for every kernel, for every channel, we accumulate into the temp buffer. Then we process all of the FFTs into U for that channel. And then do this for the entire grid for a certain channel. But the thing is, I think I'm supposed to be accumulating into G and not yeah, G needs to... Yeah, we summed them across all the kernels, actually. So this is actually max kernels. So yeah, this actually makes sense. This is fine, because this is indexed by kernel. So this is actually cell FFT dot IntelliSense. Why now do you fail me? C dot. Okay, no, we're fine. GG. This is indexed by that. Yeah, and the same thing is how we index you. If I do all of this and then it actually like is slower than what I had before, I'm gonna be so pissed. Okay, so this is getting the channel for cell FFT C that dot val. Yeah, I know what I'm doing. He has no clue what he's fucking doing. Okay, now we just have to do the same thing down here. The clean code kids are going crazy right now. They're having a stroke, man. Anyone knows how to do loop unrolling? Yeah, so this happens per kernel per channel. It's the only way to do it. You can't do per channel per kernel. The good thing, though, is that now we don't have to go per channel at all. We can just go per channel, execute the DFT. I do high. What's up? What is up? And then we can just go... Oh, we have to execute the DFT, of course, before. Cardiovascular incident. Yeah. Then we just have to do per grid size to sum it up per channel. Yeah. So I'm doing a lot of mouth breathing today because I had to take my fucking nasal medicine because of allergies. Fucking sucks. I have like a deathly allergy to dust, actually. Just something you should know about me. Keep the dust fucking away from me, bro. I wonder if we just can sum the G's. Like, why have G per kernel? Like, let's just sum it automatically. I think the reason why is because when you have a 4-panel display, you want to have the G separately, but there's really no need, is there? The problem is, then you need to memset it to 0. I wish that I had like a clear answer sometimes of like, is it faster if I memset this to 0 and then accumulate it into one, you know, array, or is it better to just set it into different arrays and then accumulate it after and avoid the memset, you know? I wish I had like a little fucking genie that I could rub the lamp and be like, oh, you know, can I do it this way or is it better to do it this way, you know? Fuck it, man. Whoever's giving me the hearts, I really appreciate that. I need it today. I need it today for sure. I want to implement RISC-CV CPU and I'm in a hole where I need to do cache policies and it makes me vomit. Thinking that all communications between parts of the code. Yeah, I got no clue what you're talking about, bro. I'm doing some cache shit right now. By the way, you sound like you would know about, like, is this a thing? Is this working? The attribute aligned to 32 bytes. Can I just put this here and just like not think about it? And it's just gonna like vectorize for me, and I can just like, you know, I don't know. I feel like I wrote this in a way more fucked up way than it was previously. Show you FFT complex, what the type is? It's just two floats. It's used for FFTs. That's why it needs to be in this order, while the rest I have it in this order because in my mind it would be more efficient for cache to have it this way. But maybe not. It should with that aligned? Word up. That's exactly what I want to hear. That's exactly what I want to hear. Exactly? Am I doing it correctly? Okay. So I think I need to go through all the channels for that kernel before we do the DFT for the channel. Or can I just do it at the end of the channel? Wait, hold on a second. First of all, this goes in there to be efficient. Can I just do this? And then iterate inside of there? Yeah, I think I can, dude. Okay, I think I just wrote the code the exact way I had it before, just in one function. I think this does the exact same thing. It loops over the kernels, it loops over the channels. Oh, no. It's more efficient because it does the kernels across every channel. Yeah. Okay. It's gonna be impossible to fucking to debug that if I did something wrong, but we're just going to ignore it. Okay, so back to what I was doing. I was going to try to memset actually I need to do, yeah, this is cursed. Oh, wait. Hold on a second. How do I have that indexed? Oh. You're gonna hate me so much for this. Oh, dude, this is actually not supposed to be for max channels. This is supposed to be for every kernel. Fuck. What else is supposed to be for every kernel? Is U supposed to be for every kernel? Is U for each channel? I'm pretty sure U is for each channel. Fuck. Actually it might not be. U might actually be for each kernel as well. Yeah, it is for each kernel. Oh shit. That sucks. Yeah. Okay, so now I have a decision to make. I either do this and just waste a whole bunch of memory, or I have these two in a separate struct as well. I think I need to have them in a separate struct for it to be efficient, right? If I'm gonna do like pure structive arrays, I don't want to waste the memory. But that fucking blows, dude. Okay, so let's call this FFT K. Okay. Per channel data. This is per kernel data. And then this is going to be reintegration data. Another struct would not hurt much, but it needs a lot of refactoring. Yeah, but while I'm here, I guess. The thing is, like, if I don't do that, I would literally need to... Basically, I would be wasting so much memory because I would have to go max kernels. Here. And this is already per channel. So... I feel like it's the only option I have. But I'm not sure like how the memory works under the hood. I'm just kind of assuming based on what I know. It's not like that big of a refactor because the data that I'm referring to only like really is used here. Like, it's not that big of a deal. It would look like that. Yeah, and now the good thing is that I can just simply add into G, accumulate into G, and then not have to accumulate later and loop over anything. Now G just has the value, and honestly we could just get rid of... Oh no, H is the thing, wait. How old is this computer? It's like 2010... 2012-ish era, I think. No, it's 32. Oh, actually, I'm not really sure. I know this version of Windows is 32. What am I doing? Oh, I can do it here. It is a AMD FX. Oh yeah, I replaced this not that long ago. I mean, it's still a bad CPU, but it is a thing. AMD FX 4300 quad core. Four megabytes of L3 cache. October 2012. Hey, what's up, Tools? Nice to see you. I'm doing well. I'm just trying to figure out how to like you know, make this auto-vectorizable, some of this stuff. So I'm just trying to refactor it to be more, you know, efficient. 4 megabytes L3, yeah. Yeah, it's pretty nice for 2012, I think. So we need to do this. You know what I'm realizing? G doesn't even need to be a FFTW complex. That's a waste of memory. G doesn't actually even get FFTW'd. It's literally, we could just like have it afloat, actually. Because we FFTW into U and then accumulate into G, but we don't actually need it to be. That would help us a lot because then we only have to memset a float. Yeah. So now we're accumulating over all the kernels. We add G for each grid spot. There's got to be a better way to do that. Hold on a second. It's actually supposed to be H equals S. And then we don't need to memset it. Because H isn't actually getting accumulated. It's some that gets accumulated per channel. Got it. Okay. So what's the more efficient way to write this? So S, we sum over all of the kernels, which becomes H. I think we can do that within this function. Or rather, inside of this function now. So we're accumulating into G now. Over each channel. For each kernel. This goes across each channel. Hold on a second. Oh my god, wait a second. Wait a second. I can't actually do this, can I? I don't think I can. I think that this needs to go out here still. Yeah, that's tough. I don't think that I can do it that way. Because this is per channel. This has to be per channel. So, you know what's the curse thing? Is that this is actually this. In practice. Even though it doesn't look it. You can try Align 64. It's 32-bit Windows, but if CPU make it much better to... Got it. Okay, I'll try it. I'll try it in a sec, yeah. I'll try it, yeah. Good shout. I will try that. The construct beginnings will be a multiple of 64. Okay, got it. Got it. Okay, so the fucked up thing is that I was actually wrong here, and this goes in here, and this is actually max kernels. It is actually per channel per kernel. Even though that sounds super cursed, yeah, that's actually what it is in practice. It's funny that I don't even know how my own code works. I mean, it is complicated to give myself a little bit of credit there, but yeah. Yeah, this needs to happen per channel. This is... I could just actually do this. Like that. I'm trying to avoid this, is what I'm trying to do. I'm trying to avoid that. Okay. So this is actually, you know, this is like so cursed, but this is actually like this in practice, even though it doesn't seem intuitively like that. It is. Man, I'm getting old, dude. I was talking about this earlier in the stream, but dude, I'm getting old. I like realized that the other day. Well, not the other day, this morning really. Talking to my sister, I was like, damn, I'm actually getting old. I didn't really, you know, it just kind of catches up on you, you know. U does have a, yeah. Okay, so we're accumulating into G. Or actually, this, you don't even accumulate now, because that is per kernel. Wait a second, wait a second, wait a second. This isn't... No, 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 you just do this. I feel the same. Yeah. Because when you're young, dude, you 26 soon? Yeah, I'm 25 now. But dude, it's like when you're young, you don't ever think you're going to get old. You know? Like that's like never on your mind. You just think like, "Oh, I'll never be like that." But dude, I'm like the guy now. You know what I mean? Like I'm old. I'm like one of the guys that I used to like make fun of. You know, like I'm old. Shit's crazy. I guess U has to stay max kernels, but maybe not. No, it does. It does. Actually, technically it doesn't, but it still doesn't matter. You might as well have it like that. Just realize, also with 25, quarter life crisis, unstoppable progressing of time. Yeah, you know, it feels like I'm like on the other half. You know, like I feel like at like mid-20s, I'm like you're crossing over this boundary now where it's like there's really like no going back, you know. There's no reclaiming the past, you know. Like when I was like early 20s, like you could still do that stuff, you know, reclaim that stuff, you know. You guys feel old at 20 something? I mean, maybe I'll feel different about it later, but yeah. Okay, so yeah, I'm thinking about this completely wrong. This is actually, I just do this. It's per channel. We are going to we can just literally add, accumulate into it across all the kernels, and therefore we don't have to do this later because we already have accumulated it into there. And so therefore G is actually just, or H is actually just G, which kind of, like, what's the point of that? Alright, peace out, Sauce. Hey, just found me from the chest engine video. It's sick. Welcome. I'm trying to record it for you is Half-Life Crisis. The reason I feel that it takes much effort to do the things we were doing 5 years ago. Yeah, you know, I mean, like, not to say like I'm super old, but I mean, maybe it also has to do with the fact that I've lived like kind of a crazy lifestyle where I definitely have like fucking shot all, like, half of my brain cells are dead, you know? And it may seem like I'm able to do all this programming bullshit or whatever, but like I can feel my brain cells working really hard most of the time. So it's also a part of that. I'm just gonna set this, I think you just set this equal. Yeah. Because I don't even divide by kernel count anymore. Are there any resources I would recommend to someone learning C and programming? I think C is a pretty simple language. I think it's mainly about projects, you know? Of course the Kernahan book is pretty good, right? But yeah, I don't really know. Like, it depends on what you want to get into. If it's operating system development, game development, you know, there's specialized resources like that could definitely matter. But like, yeah, if you guys knew like the inside of my brain, man, it's just it's not okay in there, man. Yeah, that's all right, you know. Was it worth it? Not really, but can't change it now. Not an expert at C, but doing project that is considered really hard. Yeah. Yeah, it's all about projects, really. Data science. Yeah, I feel bad because I don't actually really know much about that. I'm sorry. I mainly work on like, you know, well, you know, to be honest, just like weird fucking projects, but yeah. This is indexed by I, actually. And then this is going to be dot sum. This. Oh, and then this is also cells indexed by I dot H. Yeah. I guess the point here is that we're switching over to a more convenient cache thing, but yeah. Why do I use Windows XP as this part of the project? Yeah, I've been really enjoying programming on Windows XP. It's just more fun for me to do older programming because newer programming just doesn't really excite me. Most new graphics programming is just like shader stuff. I like the hardware kind of rendering stuff. It's just more fun for me. Okay. So all of this stuff is the old version. Yeah. And then we just switch the pointers down here. Okay. Okay, S doesn't exist anymore. But S is literally just this. Now. Okay, so we have transferred over to our more convenient cache way, right? Which is this and this. Okay. And now we're going to attempt to do that. So let's do when we initialize this, it's going to be indexed by c dot, no, it's cells, cell FFT, indexed by c dot, yeah, dot val, I0, and that's the pattern. The reason why I'm doing this for anybody who's joining is that we're trying to optimize and make things more vectorizable for the compiler. And, you know, considering the fact that I'm a dumbass, I'm probably doing this wrong, but I'm still nonetheless going to try, because if I don't try, then what's the point in living at all? Okay. Seems good to me. Alright. The mess up thing is that all of this stuff needs to be this complicated form here. So that's not really fun. Should also make sure to be setting this to my brain is cooked as well. Didn't get HPBD, but shrooms dissociated me. Yeah, man, that sucks. Frostbite damage to the ankles, that's crazy. Orthorexia, I've never heard of that. Damn. That really sucks. Yeah, I've had like, I don't want to like make this some sort of thing, but I've had like multiple overdoses to the point where like every time I came back, it's just like my brain is just kind of mush, you know? In a way, it's kind of like bittersweet, but I don't know. You just kind of gotta, you know, the way I think about it is like, there's really no point in like, you know, thinking about it at all, at least for me. It's just like the way things are, you know? It's just the way things are. Do I even... Oh, I passed in the actual thing. Okay, well in that case, we can just change how we pass it in. I don't even call that function anyway, so it doesn't matter. Certain mushroom symptom is similar to heroin or marijuana. Alright. Not really. It's more wacky, bro. It's more wacky. Something else I'm wondering here, like... Yeah. Yeah, I also didn't really even like psychedelics that much. It's just like, you know, at some point, you know, I was just kind of doing whatever because it's better than, you know, at that point not doing whatever, you know. I don't think I've ever really liked substances. It's mainly just to not be normal in your head, you know. Why do we change the grid size with the compiler? Just do constant folding? Yeah, it would. But there was this guy that came on stream yesterday who was like, hey, you should move that multiplication, and then I was like, oh, but the compiler is gonna do it anyway, you know. And then he was just like, oh yeah, you should just keep it in the back of your mind. So you know, I was just like, okay, I don't really care, I'm just gonna do it. But yeah, I'm like 99.99, they're defines too, so I'm 99.99999 sure that is going to happen. Also, like, shouldn't be mallocing this. I'm trying to think about this, but like, I don't really know what the max row size would be though. I'm trying to think. The max row size really can't be greater than did I have to also go for the rehab? I can't fucking afford rehab. I just stay inside now. Okay, so that's what I'm gonna do. I think I'm just going to do this to grid width, because it can't exceed that anyway. At least from my understanding of what it's doing. The off table stuff. So I'm just gonna not allocate it. Just to be extra efficient here. I shouldn't need to zero it. If rehab and Breaking Bad, it wasn't bad though. Yeah, well, I mean, he had kind of like meth money to go to rehab. You know, that must have been sick. Yeah, I mean, rehab isn't bad. I've plenty of friends that went to rehab, and you know, it's cool. It's just also like super fucking expensive. Which is kind of shitty, because like most of the people that need to go to rehab are poor people. So it's like, there you go, right? It's like, that's just kind of the shitty thing about it. Okay, so we don't even need this, because this function is always going to be the nabla u and nabla a separately. Like, this is always going to be, we have to pay for it? Damn right you do. It's not free. Okay, so this was the whole point of doing all of this, was, well, the nabla stuff actually isn't even, this, so it's actually, it sells idx.sum. There. We have rehab at home, exactly. Me and my fucking, you know, candles and new age bullshit. So the nabla a is what we're going for here, is going to be inside of cells. This is struct of arrays, people. What time is it? It's I don't know why I have this shit in military time. 3:42. Let's avoid also the rehabs, people. I'm not. Oh, what? What are you saying, dude? What are you saying? Okay, there we go. Gotta make sure that we don't do that. Okay. So now when we convolve H, all we need to do is, so this, for channels, the whole reason we did this, all of this has been leading up to this one moment where we are going to swap the ordering here so that we iterate the channels inside of here. Because apparently this is better. Apparently. Apparently. I'm just trying to count my fucking brackets. Alright, peace out, Neural. Thanks for the help. Thank you for the help. Okay, so this is gonna be H. Cells C dot H IDX. Oh wait, no. This is IDX HC. Yeah, it's this way. Never ever touch CMake. Sir, will I grow my hair back to what it was before? And did I color it before? No, I didn't color it before. I don't think I will, to be honest. I associate that hair with a very, bad point in my life, and so I kind of shaved my head to be done with that stage of my life, and I don't think I'm going back. I just kind of put my foot in the ground. So, everybody always says, oh, you should bring your hair back and shit, but I don't think that they really realize the kind of significance me shaving my head had at that point in time, But it did mean something to me, yeah. Search up Jmail? I don't know what that is. Okay. So we did it. We are now... So apparently, us doing it this way, we are loading less into cache. We have a different hairstyle though now. Yeah, I mean, I try to keep it a buzz cut, but then I get lazy. And then it grows out like it has right now. But I typically try to keep it a buzz cut, but yeah. Okay. So this is also something cool where we also want to do the same thing here, which is just switch these. The sucky part here is that this is different. Dennis Ritchie? I have no clue who Dennis Ritchie is, I'm sorry. So this is actually cell FFT C dot val index 0. And this is the same thing here. Man, it's gonna be so cool when we get finished, and then this is the same thing. He created C in Unix? Really? That's crazy. Oh yeah, I have heard that name before, actually, now that you mention it. I've heard that name before. Yeah, I think I heard of him on Wikipedia when I was looking at something. Yeah, so this is what I was talking about. This kind of defeats the whole purpose of the indexing the other way in destructive arrays. But we're just gonna pretend like it's fine, because that's what humans do, typically. This is .f c.x. So that's how this is indexed. Oh, sorry, I haven't had music on for a while. I don't know if even people like the whole music thing, but...
When your phone plan's as good as visible, you've got to tell your people.
Great, I don't have any service.
Linux is a kernel, not an operating system. Alright, buddy. We spawned back to 2001. We did! What's up, man? Long time no see. Long time no see. Very, very long time no see. But then again, I haven't been streaming in a long time, so it's not on you, that's on me. Black Pumas. No, I do not know that band. Alright, I'll take a look, thanks. I will take a look. Just making sure this is correct. Yeah, no problem. I always remember everybody. Okay, I think that this is efficient. Okay, so MU now. MU can also go the other way. I think. Yeah. So this F is how it's so fragile. CD data is actually really good for like music and stuff. The quality is insane. Okay. If this isn't faster, then I'm gonna crash out. I'm just like being honest. Okay. Okay, so this is the real cursed part because now, okay, yeah, this shit is cursed. Really, so what you want to do here is have the channels on the inside. The issue with having the channels on the inside is that only this is the opposite way that it's indexed. So the auto vectorization can't even work here. We're just kind of pretending like it works. I think. I don't really know any way to do it otherwise though. So yeah, it kind of sucks. But it's the way it had to be because of the whole FFT thing. We could also... We'd also technically vectorize it and put it into a separate array and then accumulate it into that later. But it's just postponing it. Fun fact, if we move back and forth a strong neodymium magnet or less strong one, corrupt the data. That's crazy. Yeah, I've heard of that. Like the magnetism thing, killing data. That's crazy. Okay, so we're nearing the end here. The good thing is that this one's an easy thing for us to do. Yeah, you have no clue how much pain wide strings bring me with these, you saying, UTFs, yeah, you have no clue the pain that I've been through because of that. Quite a lot of pain lately because of the Windows XP thing. You know the way they made it compatible. You have this macro called text that you have to put all of your when you want to print to the goddamn terminal. We've all been there. You don't really have to deal with it in modern programming. It's all dealt with for you in terms of like, yeah. You have an old disc of music cassette. What's the name of that player? Walkman? I have a Walkman, yeah. Oh, the other funny thing that they do is that this is also the macro for text. Oh, and what they had at this point was they had two versions of every single function. I can't remember what it is, but it's this and then this. This is the wide string version, and then this is the ASCII version. Do you know how cursed it is? No, you don't understand how cursed it is. You have no clue how cursed it is. I want to show you how cursed it is. Because guess what? You know this get window text A? There's two versions of this function. One for wide strings and one for ASCII. You have no clue. You want to make a window? Well, you got to create window A instead of create window wide. It's fucking cursed, man. It's cursed. It is cursed, man. That's so cursed, dude. Love it. We take a lot of things for granted. In modern programming, we really do. Okay. In assembly? Yeah, I don't understand why their translation layer like is so bad, but to make us do it all by hand, but whatever. Do it exactly like that in your C99 engine code base? Really? I never saw that before going to C89. Maybe it's just a Win32 thing though. I don't know. I want to get an old computer. I really want a PC98. I checked for them online and they're actually only like 200 to 500 bucks. If anybody wants to buy me a PC98, go ahead. I want to like make a game for it because I've been like researching and like I obviously have made music for the PC98 emulator chips before, but I also have been like really enjoying all the programming stuff that I've seen on it. So that's gonna be the next thing that I want to get. Right, so we reuse T here. I'm not really sure why we use T. Oh, right, we use T because we want to swap the pointers later. Wait, hold on, this is backwards. No, it isn't. No, it isn't. So how much the knowledge about computers and coding did the Mark Zuckerberg has when he dropped out? I think he had a lot of knowledge and also a lot of like blackness in his beady eyes. That's for sure. I need a mem set that, I think. Okay, I have no fucking clue if this is going to work. Yeah. Yeah, we have 114 arrows. So true. I was not expecting. Okay, so the first thing is do I have to do, can I do this? Is this? So apparently this aligning thing isn't working. So I'm just gonna comment it out for now and just try to get the rest working and then just revisit it after. Okay. Warning error. F-read. Oh. Yeah, the problem is now I have to like do all of this stuff. It's like disgusting. We were gonna do this later. Let's just straight up comment all that stuff out. It's fine. What is this? What's the problem? What? Yeah. What? I have no clue what it's mad at me for. So many gigabytes on this computer? 4? Okay, we're just, yeah, we're not worrying about this. We don't care about this either. What the hell? Oh, I forgot to get rid of this. Local function definitions are illegal. What? Oh, it probably has to do with something else. Okay, let's try to recompile. Okay, so this stuff... What does it matter? There's of T. What? What? Is vec3 not at the top of this file? Is that what it is? No, it definitely is. I'm not using CMake. Oh shit. It's pouring. I might have to close my window, I'm not sure. I don't think water's getting in, but I hope that you're enjoying the sound. I wonder if there's another thing named cells that's around. Probably not. See declaration of cell. Yeah, it is rain. It is rain. I keep my window open because I have like a really bad allergy to dust, and so it helps me, but yeah. I feel crazy right now. I'm not in an apartment. No, I'm in a house. Hey, what's up, Switzerland? I apparently named something else cell somewhere. What? I wonder if it's like, yo, does the Discord link work? I hope it does. If it doesn't, you can try. I know that I think it's a new one. I just try to get a new one, a new Discord link. If that doesn't work, then I can do that. Sorry, I'm trying to figure this out. I wonder if it's the size of the grid that's the problem. Like, if I just artificially, like, bring this down to, like, 10 by 10 or something. No. I feel like I'm gonna feel so dumb when this is done. Can you not do that? Is that the problem? Or something like that? No. Did I like... Hold on, do I have... No, max channels is up here. Max kernels is up there. So all the defines are there. This is really bizarre, man. Am I just like missing something? Like, what is the problem? On our devices, I'm not sure if I'm at that portion yet. It's weird because it's only cell itself and not... I'm just going to restart and see. Okay, no, it still is... Like, what? Let's look in all open documents. Okay, so let's just comment this out because this is also using the old version of cells. Oh wait, hold on. How do I find to go back. Okay, whatever. Keep going. Clean up, you know, do that. Yeah. VS Code also burn out? Yeah, you're telling me. Just gonna, you know, everything that is polluting the namespace has to go. Absolutely has to go. The central difference thing has to go. Okay. I don't know, like when I was writing this, it was doing this properly. I also don't understand, like, why is it not finding cells? Like, when I hover over it, it says cells, cells. I'm just like, what? Yeah, it's coming up, fine. Like, what? It's this file specifically. Like, LSP, it comes up in LSP. Hold on a second, hold on a second. It's only in these functions, though, isn't it? Cellular automata. Wait, so... Okay, hold on, hold on. I'm close to figuring it out. I'm doing calculus in here, yeah. So why is the namespace polluted here? It's specifically here. T is not a member of cell. But it... Oh my god, I'm a fucking idiot. Oh, I'm an idiot. I'm so stupid. I'm so stupid. I'm so stupid. I'm so stupid. P isn't even a variable. P isn't a variable here. I don't want to talk about it. I don't want to talk about it. I don't want to talk about it. Okay. So the problem is... Okay, so we can't swap the pointers. Okay, so that's very simply put. We can't swap the pointers. We cannot swap the pointers like I thought. I'm very sorry. Wait, no. No, we can.
Like an illustrator or a graphic designer, you have your own.
We just have... This is from Cell FFT.
If you want to animate, you have your certain app to do that. Whichever app you choose, you enter an infinite realm of possibilities. Adobe Creative
Okay,
Cloud
this guy
has the
needs to
tools
stop talking to me right now. Okay, so since we can't swap the pointers anymore because of how we did the thing, so I don't know if this is actually going to be faster because we kind of we're accumulating into T. What we could just do is just kill Val instead. And then just accumulate straight into Val. Since we're doing it either way. Yeah. Okay, nice. So then we don't have to do this. See declaration of cell. You're a declaration of cell. Bell is not a member of cell. Oh, I meant cell FFT. For physics country. Yeah, I mean, that's what this is. It's literally a physics simulation. Okay, shut up. Shut up. Memset, cell to void pointer. Oh, this is, inside of a function that we don't really care about. We do kind of care about it, actually. Yeah. Okay, warning, error. Back undeclared identifier. Okay, so this is the annoying thing, is that we can't swap the pointers because we don't malloc them anymore. And so, yeah. I mean, we can't avoid the mem copy here. I wonder if we can... No, we can't. Yeah. We could have just malloced it, by the way, and not... Yeah, but... We can try that later instead, but... Yeah. Okay. Okay, so this doesn't need any... So I studied C and C++ from YouTube, but no teaches me how to use it for making animations. You just linearly interpolate most of the time. Alright, so we need a... This is cell FFT C dot val into cell FFT C dot T. I think C is as problematic. Do people really make it out to be problematic? I don't think that they do. I mean, maybe if you, like, you know, only listen to, like, people who, like, do these, like, new programming languages or whatever, but C is an amazing language, and it will always be an amazing language. I don't think it's problematic. Right, so we can just put this straight into here because I don't really care right now. What? Oh yeah, that's that. Oh yeah. Oh, let's just call this vval. I don't really. Yeah, so this is that. I don't care right now. I'm just trying to get it to compile. At this point, would I prefer C++ over C? No, I would not. I'm not in really coding in C++ right now. I'm just compiling in it because of C89 on this old machine. Yeah, so this doesn't even need to take in arguments, right? Kernel, undeclared identifier. Yeah, so just do this. Nothing crazy. Is that it? No. T is not a member of cell. I meant to go cell FFT here. I just forgot to change it back. Yeah, this isn't gonna work. I have to specify the kernel count, so that. Yeah, this is so goddamn complicated. I'm like 99% sure that this isn't going to work because it's so complicated. Rustig and Artus, will they will never replace C now. Okay, so that's the same thing. Okay, down to 5 errors. Okay, so I just forgot to change the function definitions for these. Function definitions, function signatures. I mean, they're in VS Code, yeah, but with a refactor like this, it's that this complicated, you can't just really do that. Which IEM, it's truth ear, I believe. Okay, so we memset sum, it's actually cells dot cell yeah, that's a good question. How do I actually memset that to 0? Is there a way that I can 0 that easily without actually doing things? No, there isn't. I literally have to loop through it and then do it myself, is what has to happen. I have to literally do it myself. There's no other way for me to do it. It sells I.sum. Oh yeah, I just have to loop through the... Oh. No, yeah. Yeah, because Oh, structive arrays. Do structive arrays. Truth here is 0, 2. I'm not really sure which one it is. It doesn't say on it. Okay, 2 errors left. From parameter 2. Wait, hold on a second. This needs to be to grid size. Yeah, what was I thinking? I don't know what I was thinking. Okay, 1 error left. Cell does not define. Oh, yeah. So this is cell FFT dot val. Yeah. Okay, I doubt this is going to work. Alright, good night. Good night, Shari. Yeah. I'm not surprised. I'm probably doing something wrong. Which is not surprising since it was a very big refactor, so. I want to actually just like, I think the easiest way for us to debug it is just to get rid of this stuff and then see if we can just, okay. Okay, so this still works. The bug has to be with our reintegration, because this all works. If it's faster, I don't think so. I do not think it's faster. In fact, I think it's like slower, so. I don't actually know if it's that much slower. It was always kind of slow with multiple channels. Like this version has 2 channels. But this, once again, is without reintegration, so... Okay, but at least we know that we did that right. What I wonder is if this mem copy is slowing us down. Sorry, I need to. It's really hot in here because I had my space heater on. What a long refactor for it to not even be fast. Yeah, I assume that if we're gonna do mem setting like this, then it probably isn't even faster. Well, you can't say that I didn't try. I did try pretty hard actually to get it working. And I did get it equivalent. It is equivalent. I think before we try to like do any different allocation or whatever, what we should do is we should try and figure out what the issue is with the reintegration. We probably did something wrong somewhere when we were refactoring. So this is Nobble A, so this looks absolutely correct. That does look absolutely correct. And then this is just we changed the iteration order. And then this is H once again. So this is H, it goes per channel, per IDX. This is absolutely correct. And then, yeah, so that's correct. Yeah, so this is where it gets complicated. So I'm assuming that something here is wrong. So we do use the cell FFT val, which we know is correct. Okay. It looks correct. I'm pretty sure that we were using this for that. Oh, yeah. Yeah, so this is supposed to be val. Okay. That might have been it. So let's just give that a shot now. Okay, that apparently wasn't it, because everything is immediately dying still. Where'd I put my... oh, it's here. Our border isn't torus, so it should be going into this code anyway. And that looks correct to my eyes, but... so we zero this. Oh, and then we roll. Oh, I see what's happening. Oh, yeah, so that's why, okay. So that's why we need a second thing to accumulate into. Because when we roll, we're rolling from val. And so we can't accumulate back into val. We have to accumulate into another variable. And so we have to choose what array we can repurpose. Which array can we repurpose? I think we want to repurpose temp, and the reason is that we can just like we can mem copy it after. Which, it sucks to mem copy, but it's literally the only way to do this shit, so. The sucky thing is that you have to do both a mem set and a mem copy, and there's really no way around it. I wish that we didn't have to do it, but unless we malloc and then switch pointers, then this is the way it has to go. And I think that that's what we're gonna end up doing, is mallocing and switching the pointers again, but yeah. Yeah. Okay, well this is still giving us problems. How? We need to make sure that do I touch Val otherwise? Probably missing something here. Just for the sake of argument here, let's just also zero back. Let me try something here. Let me try just like cheating and then putting this everything to 1. Seeing what happens. That's exactly what I was worried about. That might not actually be indicative of anything, really. Oh wait, no, it should be. Because we're setting everything to 1 regardless of anything. What I'm trying to see is I'm trying to see if Uh... Yeah, let's just loop it inside of here just to test what's going on. Because I have really no way to know otherwise. But how is it dying? It should always be 1. This should always be 1. Unless I messed something else up somewhere, but this should theoretically be the correct code. God, it sucks when you fix a bug and then you think you have it and then it's not actually the bug. Should also technically just like move this out here for it to be faster. Okay, let's do some breakpoints, I guess. I don't know. Oh, I'm in release, so okay, so we're getting values into F. We are. And our offset array makes sense. I'm not sure what the values were beforehand, to be honest. God. I think if any of this stuff was off, then we would actually be getting some output still. You know what I mean? Like I don't think this stuff is off. Because we would be getting something out still. If any of the Sobel convolution stuff was off, which it was last time, we would still be getting something visual happening, and everything wouldn't be dying out completely. Uh, oh, here's something that it could be. Hold on. No. It's not that. I had this idea that maybe the back array is being used and it also needs the same data, which I think is technically true, but it's not that. Like, obviously, if I get rid of this, we're gonna render fine. Right? Yeah, because we don't touch val. I wonder if the order matters. Actually, I wonder if this order matters. I wonder if you need this out here for some reason. Technically, it should be the same, but I don't know. The order matters. No. Oh, yeah. Hold on a second. Was that actually... Oh, no, we weren't mem copying. We weren't mem copying it, so yeah. It's gonna be the same thing, yeah. Oh, I'm in release. Yeah. Did I change any of this stuff? Any of the initialization for that? I stopped malloking it, but I don't think that that should necessarily be the problem. Yeah, this is exactly the same. Okay, let's try to go back to allocating it. I guess. I doubt that that's... Hey, Arya. I'm just going to go back to allocating that, but, like, it shouldn't really be. Welcome to hell. I'm trying to, like, make things more vectorizable. And the refactor, it works for half of the code, but there's some bug that I can't seem to find right now. I changed everything to structive arrays, and now everything is just, yeah, like the first part works fine, but there's some bug somewhere at, you know, whatever. It also might be that the sum is wrong, that like all the way back. This sum might be. No, but we set it to. How many nested loops is that? It's a lot. It's necessary though. It's necessary. It's the reason why people haven't done 3D Sobel convolution. It's cursed. It's cursed. Believe it or not, this is actually the fast part. The slowest part and the most painful part is this, which it looks a little bit innocent. Just looking at this, it looks like, oh, that isn't that bad. And then you go into this function called roll. And then you realize just how cursed it is. Yeah, it's pretty fucking cursed, man. Yeah, so what this roll does, it's the same thing that they do in NumPy. It's just this is implemented in C. In NumPy, you would just do numpy.roll, and then it would just roll the array for you. But no, I have to do it by hand. So this is what roll does, right? Is it, you know, it takes an offset and then it rolls around the array. So what this is it's mass reintegration, which is basically we are moving the mass. You can go to early on in the stream if you want to like rewind to see what it looked like before I tried to vectorize it, but it looks really fucking cool. It's just extremely slow in 3D, which is, yeah, exactly. That's what I'm trying to do. But to get it into simmed, I have to get it into a vectorizable format, which is what my goal was here. Was now everything is SOA. So this, right, is so that you can load in, like you can load in 4 of these floats and process them at once, right? But you can't do that if they were just like separate, right? So that's what I was trying to do. However, I made a bug somewhere, and now I have no clue how to debug something like this. Yeah, it sucks. I don't think any amount of breakpoints is gonna solve this shit, to be honest. Like, yeah, it's just like, it just has to be off somewhere, you know? And by the way, this being ZYX is, that has to be backwards. So it's not that. You know, I'll be here for like another 5 hours and I'll eventually figure it out. It's just kind of painful. I kind of should like walk through the backup of my other code bases version of this, and then like just that's what I'm gonna do. So I'm just gonna like I have my 2D implementation, and I'll just pull that up on my other monitor and just walk through it just to make sure that everything works. Okay, where are you? Okay, so let's walk through it from the top. Okay, so without sum, all of this is correct, and the indexing, we are adding this sum for right, so that's per channel, yeah, so that's the next one, but this is that. And this nabla A, yep. No, yeah, the indexing for that is correct. Alright. Yeah, okay. Then down here I have this, so. So we're looping through all the channels here. I wonder if it's like an ordering issue actually. So if I No, I don't think that it is an ordering issue. It can't be. Because it should be exactly the same. It should be exactly the same. I guess I have to check if our H is correct. I believe that our H is correct. H for the channel. Yeah. Yeah, that's correct. And I do set the sum for each to 0 at the beginning. So that's for sure working. So I think that those are solid. I would definitely fuck up all the data downstream if that stuff wasn't solid, but I think it is. We copy into val from back, and we already know that that part's fine. So I don't think that the sub-L convolution is bad, because that would be really hard to mess up. Okay, let's go to F. We do the val for each channel index divided by channels times itself. Yeah, square it and then clamp it between 0 and 1. Yeah, that's exactly how it was before. That's exactly what it was before. And then the indexing for F here is, yeah, nabla U times 1 minus alpha nabla A times alpha. Yep, that's exactly it. All of the indices are the same. Yeah. So I feel like that's guaranteed to be correct. this, you can't mess that up. At least I don't think you can. Yeah, I guess I think that our indexing is correct on everything. I can't really think logically on why the ordering on the iteration would matter, but I might as well just give it a shot to switch everything to the original order and then see if magically it does change it. Because that's really my only idea at this point, is that that is my only hope at this point. Okay, let's see. Okay, it works. All of a sudden it works. Okay, so that is the bug. I mean, not the bug, but I probably didn't think here. For some reason somewhere here, by the way, why it's lagging is because we were in debug mode. But it may be that during the roll we can't go channels here. For whatever reason. I'm not really sure why, but if I had to guess, it's during the roll. Oh no, it's not during the roll. Wait, so I think I'm just going to, I know it's like annoying that I'm like brute forcing it or whatever, but I think at this point that's the only way I'm going to figure it out, because it's really hard for me to logically kind of figure out why the order of the iteration would matter. Yeah, so this is working like it did before. It almost feels slower. I mean, not to be like a jerk or whatever, but it almost feels slower. So that works fine when it's inside. So is it really... It's either F or the Sobel convolution that's upset at me. Okay, so it's not F. So it's really the Sobel convolution all along. That was the one thing that I thought it couldn't be. It doesn't allow you... Wait, what? Wait. Wait, what? Wait, what? Wait, so what fixed the bug? I don't even know. Oh, that's sick. Okay, but it's still like insanely laggy. I mean, this one does have 3 channels, but... Okay, so I don't even know what the bug was, to be honest with you. This stuff is just super sick. I love how you can repopulate the field. I have it on tab that it just like repopulates the field with data, and then it just always settles into the same pattern. Man, it's so sick. It still is just as slow as it was before, though. Before we did, 3 hours of code. So... okay. I wonder, so how slow is this specifically? Because if we just literally do this will give us an idea of so it is pretty slow. Displaying the FPS, can we tell if it's slowed down or not? I guess, but then we wouldn't have a reference to it, but it's definitely slowed. It's definitely slowed. We can do, so something else I looked up is this query performance counter. We need a large integer. I have no clue what type that is, but we're just gonna make a large integer. R. And we will just put that into R. And then, so this is something that I looked up that you can do here. And then large integer E for end. And then just we have to actually do the thing here. So char really makes you love modern programming, doesn't it? No, let's just make diff. It's an integer apparently, so int this diff, and then we're just output debug. Fuck, what's the name of it, man? Output debug. There's something. Output debug string A. Yeah, it is the thing. So string A. Okay. So that's, we're gonna log it. We're gonna log it here. Okay. Large integer does not define this operator. What the fuck are you talking about? It's an integer, bro. What? Wait, what? What are you talking about? What are you talking about? Just subtract them, bro. Wait, what? Does not define this operator. Okay. We're just gonna call them ints, and then if it doesn't... Okay. We gotta go MSDN here. The hell is a large integer? It's a union? It's a union. Okay, so I need to get... Okay, hold on. So query performance counter receives the performance counter variable. Okay, but is that in counts? Okay, but... Okay, but is that the high word or the low word? We're gonna make our own timer class. Not a class. God, no. We're gonna make our own timer function so that we can automate this. But I just want to figure out how to do it in the first place. So I think that it's either high word or low word. And I don't know which one it is. So we're just gonna try both until the result makes sense. I don't know. Typecast cannot convert from large integer to D-word pointer. Are you fucking kidding me, bro? Okay, give me my output, bro. Okay, let's see what it was printing at. Oh, it wasn't printing out anything. Wait, what? What? Maybe this has to be a float because... Oh, yeah. Yeah, you're probably right. Wait, what? 0. 0, 0, 0. Okay, let's try the low word. Nah, it's gotta be the low word, right? Yeah, it's gotta be the low word, right? Why the fuck is it negative? Wait, how is it negative? Oh, wait, hold on. This is performance frequency. Like, it's the same thing. Wait, what? Did we just time travel? That's what I'm saying. Okay, let me just do a quick Google. Query performance counter example. Okay. So you get the frequency first. Then you get the starting time and the ending time. What the fuck is that? What 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 is that? E dot quad part? Nah. Ah, man. My bad. Like, what the fuck are you talking about? What the fuck is a quad part? Quad part? And now you have to multiply it times 1 million. Ah, yeah, my bad. Fucking what? 1 million. Okay, got it. Yeah, no problem, bro. I'm all over it. Okay. So this is in microseconds. Oh, so you can get it in seconds as if we don't multiply it at all. That was microseconds. So okay. So this is 0.06 seconds. Okay. Okay, so let's do this. How about this? Let's make a timer struct so that we can just put these time. Why is C++ big? It's not C++. It's just Windows, bro. It's literally Windows problems. It's like Windows is just fucking BS, dude. Okay, so let's. Or maybe I'm just dumb. You know, with everything I say, it might just be possible that I'm just stupid. So, let's make a timer. I don't know why they don't do this for us, why I have to do this, but whatever. Timer, blow. You know the Laura Nyro song, Timer? Yeah, that song's awesome, man. So we got the frequency. Or just the freak, you know? Bit of a freak. And start and end. We'd also just straight up make these, you know, floats or whatever. Whatever, bro. Okay, so let's just straight up, let's just do like a static inline thing here. Static inline void start timer, and it's gonna take in a timer pointer timer. Okay, and then all we're gonna do is we're just gonna do exactly what we did here. I'm going to do it here because I fucking already forgot what I was talking about, dude. Okay, so we're just gonna do, I usually use chrono break, like League of Legends, frequency, and then timer R start. Yeah, I know what I'm doing. And then end timer is just going to return a float. We're just going to query performance counter into the end. And then it's just going to do the thing for us so that we don't have to do it inline. It's just going to return that in seconds. Return that. Fantastic. Okay, so now to make sure that we got this working, we're gonna make a timer reintegration, and then just pass it into start timer reintegration. I shouldn't have named it something so hard to spell. And now we will float diff equals end timer regression, and then boom. Okay, so let's see if this works. Okay, guys, chill out. What's the problem? Left of quad part. What's it? Oh yeah. I'm all over it, bro. I'm all over it. Bro. I'm all over it. Okay, let's see if it works. Did it work? Yeah. Damn right it does. Okay. So now all we have to do is let's also make a function that just like prints timer. Actually, no, yeah, let's not do that. Let's do it all automated and pretty. This is exactly how I did it with my game engine back in the day. Oh, all the way back in the day, man. Oh, how the time flies. Okay, so we're just gonna do shit like this. We're gonna start off here. Make a reintegration thing here. Okay. We're gonna start there, and then we're gonna go down. And then we just end here. Right? Start timer reintegration, end timer reintegration, get the rdiff, and then at the end we'll print them all out just to see what it's like. Okay. So let's just get rid of that, get rid of that. Even display the time FPS inside the window. Yeah. I don't really think I want to do that though. What I want to do is I want to profile which parts are problematic specifically, because I'm going to add timers now for every single thing. I'm just going to do 0.4f for rdiff, but we need to do timers for everything now, so that's what I'm going to do. I'm just going to do Sobel both in one because they're both the same. F, mu, and that'll be it. I just want to see where the bottlenecks are. Yeah. Okay. And then we also have to do the thing for we have to do the same thing for the rendering as well. So I have to do that as well. I have to remember how to do that. That's not going to be easy though. I have to figure out, I'm trying to think what I have to do. It's not going to be easy though. Okay. This is going to be a lot more than this. So let's just do a 400 buffer. And so we just want to do, this is Conway. Then we will do Sobel. And then F. Mu. And RI. CDiff, SDiff, FDiff, MuDiff, RDiff. Okay, so now let's see. Yeah, reintegration. Conway actually gets done in 0.0061. Sobel is actually 0.0198. So Sobel convolution is actually more than 2 times this, which is actually incredible. That's incredible. The Conway stuff, by the way, is not just Conway's Game of Life. It is FFTs for literally everything. Literally everything. So that's crazy. So the reintegration step is by far the craziest thing. Even more important than any of this, though, is going to be testing the rendering itself, right? And so this, we need another timer here that is going to be outside of here, timer render. And so this will do the entire render step from here, and then we'll end it there. And this is going to be very enlightening to us on what we should focus on next, because I'm not really sure what's the bottleneck. So let's do that. So rendiff will tell us what okay, let's take a look. Yeah. Wow. So the rendering is actually only a little bit less expensive than the reintegration. Sometimes it's as expensive. Sometimes it's even more. Wow. Wow. Wow, 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 wow. Okay. So, let's follow along here to try and find out more what's going on. The problem is multi-threaded timers is probably not good, but we can try to figure it out. Yeah, so let's... Okay, so here's what we'll do. I figured it out. So here's what we're going to do. I'm going to print out from each thread how painful it is inside. Okay, so... Okay. And now we just have to print this stuff. I want to know if the driver itself, like for DirectX or whatever, is actually the problem, is actually the bottleneck, or if it's the methodology for us iterating itself. Because if thread time takes a long time, but individually they finish early, then that means to me that it's, yeah. That's exactly what I was worried about. All of the threads, by the way, finish is 0.01 seconds, but the frame finishes at 0.05 seconds. So that means, so that's what I was wondering about. I don't even think that it's this that's the bottleneck. I think the bottleneck is literally the it's possibly even this itself. But how do I check that? We also could check our actual render step here. It's probably important for us to actually have this as well. So let's do this. I'm assuming that this is going to be like nothing, to be honest. But then again, we have to loop through the max threads here. So let's okay. Okay. So profiling. Okay, so this will tell us the frame makeup for each part of our rendering loop and our simulation, so that we can figure out what is bottlenecking us. Okay. Hey, so the font that I use on Windows XP is actually Fixsys. Okay, so thread finish. This one took a while, but maybe that's because I was... Okay, so render loop is nothing. R start, exactly this. 0.334. 0.327. Exactly. So our insanely expensive reintegration loop that is 0.02625, this huge expensive thing, almost half of that is R start, which actually is just this little piece of code here, and all it does is it locks the draw buffers, and it's my guess that D3D just really doesn't like that. So yeah, our start is really painful for us. Reintegration is of course very painful for us as well. Like I'm not sugarcoating that as well. We need to really work on that. But our start, yeah. Our start indeed. The Sobel convolution, our start. So now's the question is like, how do we fix that? How do we fix that? Oh right, it's also create thread. I wonder if it's actually create thread that's the problem as well. Yeah, it might be. Okay, so I think that this is the easiest thing to fix, though. Like, doing the reintegration stuff. Line 155, use grid size. Yeah, sure. I mean, sure. Sure. But yeah, the fact that the thread time per thread is only a fraction of the thread creation time is really, really not good. So and I wonder if it's the locking or if it's this. We can actually just literally test that right now. Just move this inside of here and just find out how bad it is. So that's nothing. It's 841. Actually, no. I mean, that's not nothing. That's 84, then 16, then yeah. So that isn't nothing. That's actually that is the entire thing. So it really isn't the thread creation. It's actually locking all of these buffers. Yeah. Okay, so I think what we need to do, right, is instead of having this just locking all of the buffers, I think what we should do is we can still have a front and a back buffer. I think that that's a good idea. But I think, to be honest, I think it's better to just have one massive buffer. Also, something else that I was thinking about earlier is that these buffers actually don't need to be this big. I made them with a bunch of headroom, but technically you can do 16, I think. I'm not entirely sure, but I think that's the maximum amount of vertices that we're doing. I don't know if that's going to break something else somewhere. Probably this, right? But I want to see if there's any performance increase from doing that. Yeah, there is a pretty insane increase for doing that. I wonder if there's a way for me to... Yo, what's up, Absy? Wonder if there's a way to avoid... Yeah, this is for D3, D11, but basically, I think that, I'm doing it correctly for D3, D9 already. So, I saw it had this context map. I think it would be device map. But yeah, we don't have that. We don't have that. So, unless if that's a different thing, but yeah. Okay, well 16 actually like really improves it. Which makes me kind of think like, what if it's that mem set that's also probably expensive, but... Oh, wow. Wow, that mem set was actually the whole thing. So we just lost... Okay, so that was 0.03 seconds of our frame time right there just taken off. Okay, so maybe I don't need to refactor everything. I thought it was this that was the bottleneck. The reason why I zeroed it was because I thought that there was a bug earlier, but I think it automatically is zeroed. So, okay, well that's cool. Yo, what's up, Basement Dev? Yo, indeed. Okay, so then it's really comes down to the... It's pretty sick. It is pretty sick. It is annoying that this is happening now. Did we score any progress today? Yeah, I mean, not really sure. I did refactor everything to be structive arrays, so that it's easily vectorizable, but I'm not sure if we did it properly. What's also pretty confusing is that all of these threads finish at 0.148 at the same amount of time, and then the frame finishes at 0.419. So that's also pretty confusing. I almost wonder if... Damn, C++. Yeah, I wonder what's happening here. Do they all start at the same time? Not necessarily. I guess, you know, that... No, they all do start at the same time. They do. That is guaranteed. Let's try to see before... Yeah, the thing is we have to... Oh, yeah. So, here we go. Let's see this. How expensive is like close handle? Thread finish, render loop finish, thread finish, frame finished here. So it is 100% us waiting for multiple objects, or closing the handle, or unlocking the buffer. It's one of those things. So let's go here. It might be unlocking the buffer, but I don't know about that, because locking them is so fast. Let's see. Frame finish at 0.234. So waiting does lose us like a little bit, like 0.03 or something. I almost wonder if closing the handle is a problem. I guess we can check that, you know, like this, but I don't think closing the handle is necessarily necessary. Okay, so closing the handle, not closing the handle is extremely fast. So there we go. Now, if that's going to have bad consequences later, I don't know. But there you go. That's another 0.03 seconds shaved off. Now, reintegration in Sobel convolution. That's the next problem. So our rendering happens is 0.0176, 0.0160, which is, you know, fine. Now the big problem is this. Sobel and reintegration. But I need to also, I think this is also not good enough. This needs to come down a bit more, but our next big problem is those. So everything else is super fast now. Okay, so yeah, I really actually didn't expect the 3D Sobel to be that painful, but I guess it makes sense why it is. But I want to test something. I want to test this ordering, see if this changes anything at all. It's actually pretty strange because earlier it wasn't making this pattern. It was making this pattern, but I think it may have to do something with the way we initialize now. I hope I didn't mess something up. That would suck. It's very possible that I did, actually. This is not incredibly smooth anymore, like it was earlier. Yeah. Yeah, that doesn't look correct, actually. This is all fine and dandy, but I need to make sure that it works. That's the most important thing. So we can't, we have to make sure that it still works. I'm telling you that this pattern wasn't what happened earlier. The reason why we're lagging so much is because of the amount of string printouts that are happening. Yeah, like that, for example. We're getting a lot less calm patterns. Like that is really not good. Like that's normal. What am I using for the debug UI? Just Win32. Some of it's normal, but this like sort of flashing. Yeah, like this is what it's supposed to be. Yeah. Yeah, I'm aware. I don't really know if we're ever going to get to 30 FPS, but I think we can get closer. We're going to have to take some shortcuts to do it, though. There's literally no way that we can just optimize the reintegration step. I want to make it absolutely clear that the reintegration step is incredibly expensive in 2D, let alone 3D, you know? Like that, you're kind of capped at 100 by 100 as a grid in 2D, right? So it's kind of really difficult to do it in 3D. Maybe this is fine, actually. Maybe I was freaking out over nothing. The flashing is kind of sometimes inherent in flow Lenia, so I don't know if it's necessarily... Like sometimes you just get a bad seed like this, where it's just very chaotic. And I think the messed up frame rate kind of makes it more buggy looking like this. Yeah. I just want to make sure before we start, like, you know, messing with stuff that I didn't mess something up. Because I kind of need to know that now before I, like, go down a rabbit hole of, like, messing with stuff. So it doesn't appear that it's this. But I still want to check the I still want to check the size of the buffer itself. I want to make sure that like maybe 24. Kind of worried about the headroom. The thing is, it may look like it's jittering around. The problem is that we are we only perform a simulation step before we start doing the rendering threads. Does that make sense? Are the specs of the system as outdated as its OS? It's not actually even like that bad of a system. But I mean, I think, to be honest, what I'm doing here would be just as complicated and hard to run on a new computer, to be honest. Unless you somehow got the array rolling onto GPU. It's kind of a reason why nobody has done this, but yeah. Okay, so I think the first thing we want to do is, I think the easiest thing is possibly the Sobel stuff, just to get our feet wet with it. So I think we want to multi-thread it. What libraries? None. Windows, Win32. We can multi-thread this the exact same way that we thread, yeah, Windows .h. The same way that we thread the rest of our stuff. So this could be just divided by max threads, right? Yeah, this is actually not that bad. The problem is, like, is the overhead worth it? Probably, right? It's probably worth it. So okay, so if we're gonna multi-thread this, I think what we want to do is actually just like create threads at the beginning, create a pool, and then do create event for it, because we're gonna need to send threads on jobs here, right? So I heard about this create event thing. I don't know how to do it though. Oh, not create thread. The parameter is true. The initial state of the event object is signaled. The name of the event object. Okay, so thread blocks until wait for single object for the H event. What is wait object 0? Signal the event. We do not. Okay, so set event for the H event, and then reset event, close the handle. Okay, but how do I make different events? That's the question. How do I do different? LP name, the event of the event object. I'm just wondering, I need to create events. So what I'm going to do is I'm going to create a thread pool, and then I need to do, create event, signal to all the threads to do this, and then do this, right? And then we need, during rendering, we're going to send them and create event here as well. So that's what I'm trying to figure out right now. Yeah, so I think we're gonna go back. I already had this set up, and then I basically tore it all apart because it wasn't working. But right now, this is something that's necessary for us to do. So we have to make a thread loop, and apparently this you can no. So apparently this can take in a apparently this is D word, at least the example that I'm seeing here. And that param is what is going to be the event. Okay, so we wait for a single object here on the H event, infinite, and then we need to check the wait object 0. What does that even mean? What is wait object 0? I have to look that up. I'm guessing like this has to be a loop though. This has to be a while loop. Right? Has to be. Okay, but okay, hold on. No. Okay, I got it. I understand now. This is actually going to be an array. Yeah. An array of handles to different events. Right now we'll have 3. Yeah. And so we're gonna wait for multiple objects. right? That's the function, right? Yeah. And so with a count of 3 and the handles there, and we will have this to false. We just want to get the first one that we get. How do I know which one we got, though? How do I know which one we got back? Return value, b weight all is true, b weight all is false, the return value minus index, okay. Return value minus weight object 0. Okay. It's not, this is not max thread. This is max events that we need. Okay, so I have to make an enum for this. For now, we'll just have 3. And then this one's going to be render. And this is going to be event max. And then we'll just use that. So the thing. Okay, so we'll just have a switch case. Why did it do that? And all this is going to do is just call the functions. Would I say that I exist? Yeah. I would say that. I would say that I exist pretty hardcore, man. Okay. So what we'll call is Sobel convolve. Yeah. What is this? What did I call this? It is pretty cool. It is pretty cool. Okay. So how we're going to do this is at the beginning here, we are going to create threads in a loop and set it to that function. And and pass them a loop to that array. We'll just make that array here. Thread events. Wait. No, this is handle. Yeah. And we just need to pass that into the thing. Yeah. I think I'm allowed to initialize this to 0, yeah. So we will create threads in here. We do want to make sure, so this, all of this stuff can go in here. We are going to need to change some things. Like V is going to always be a pointer. Oh yeah, how's V going? Yeah, we have to just change that manually, then the V pointer, but yeah, so let's not even worry about that for now. But this is going to call the function that we just made called thread loop. And we are fuck. How do I avoid making this not complicated? I think that I have to. I need to give it okay. That's what we'll do. Okay, so my goal is to now put this on this. We need to pass thread data in. It just needs to happen, so that's what that's going to be. So okay, so we'll just pass that in. And so we have to change the code here because this is going to now be td pointer t is that, and then this will be t events. There we go. I have no clue if this is going to fucking work, to be like honest, man. I'm just trying it because why not? I'm just trying it, man. Yeah, we can get rid of some of this shit. This is no longer going to be a thing. What we're going to have instead is a Okay, here's what we'll do. Here's what we'll do. On thread initialization, we need to set a variable inside of the thread. My projects will always become like this. We need a B size, which is buffer size, the bounds size. So, the problem is that bounds are in cell size. So I think we need to divide the cell size out. Yeah. Okay. Okay. We'll calculate the bounds like that. This is going to give us the amount of... Right, I just said that we have to divide it out cell size. Do we have to divide out cell size? We do. I think you do have to... I don't think that you could do it the other way. I think that you have to do it this way. Maybe I don't know what I'm doing though. Okay. You want to code it yourself? Let's do this for max channels now. Shit. No, this is current channels. Because this isn't for allocation. This is how much our maximum per thing. And this VIDX will no longer be a thing. We're just gonna keep it on the buffer. Yeah, so we have that there. Okay. So I'm gonna get rid of this, and we still need a back and a front buffer, I'm pretty sure. But we're just gonna share it across threads. Oh wow, I don't like that I just did that. Yeah, so let's just have it max channels, yeah. And instead of this, we're just going to go back to this. And now each thread is going to write to its own section of the buffer. And that's how we're going to do it to avoid any mem copying. So that's what I calculated here, was the amount of size it's going to take per thread for when we do that. So let's not even worry about the Sobel yet. Let's just try to get the rendering working. So this V, the thing is, we can actually just set that V once and forget it. Because V will always be the same pointer. It's just gonna get filled differently. There. Oh, actually no, because this changes it. Yeah, it's not the end of the world. Let's just yeah, so let's just do tdi dot v equals v at here once we fill in the pointer, and then we'll just get rid of all of this. We want tdi dot vidx equals 0 though. That's important. And now instead of create thread, what we'll do is create event, right? So I think you do null here, do manual reset initial state. Let me see how I do this. Okay, so we have to create the event earlier. I'm sorry, I hit the mic. Okay. So we have to create the event here. So manual reset event. I think it is a manual reset event. False. I'm not going to do wide string. I'm just going to do this. And we will call it Sobel. I don't know how to get the name later, but whatever. Okay, so we get this is where we get the handle. Okay. Okay, got it. So handle SE for this. Okay. And we will just, that's what we'll initialize this to. Yeah. For each thread. Okay. Okay, so when we set event, Now we just refer back to the handle. Yeah, we do this outside of the loop. We set event here. Once we're done setting up, we set event for RT or RE. And then later, okay, so I don't think we want manual reset event. The master thread must call reset event to change the state back to non-signal before writing data again. Auto reset events handle this automatically. Okay. We need the offset. We need the offset. Okay. Now during rendering, I need to add the offset every time we write to a vertex position. Also, we're going to use td vidx td b offset. Now, when I render, oh yeah, the issue is that that we need to render from all of the offsets, but oh, actually, okay, got it. Okay, so we need two different sets of we need two different sets of vidx in here. Yeah, so let's just literally link it by the back and the front buffer. So this it won't be this VIDX, it's going to be the TD VIDX. TD the VIDX. Why does this have a problem? I don't know. Okay. That's that. Okay. So the VIDX reset needs to also write into curve buff, because curve buff is going to be the one that's that it's going into. Yeah. Yeah, we never clear the other one. We touch the other one. Okay. And when we're writing into it, this has to be curve buff now. Okay. I don't know what else there is. I don't think I'm rendering from the offset, am I? No, I'm not. I need to do that. Okay, so because there's going to be blank space in the buffer, we need to start at TDI dot. I don't know why this is giving me a fucking problem. It's annoying. This is going to be the B offset. Always. Why is TDI not working? This is a global variable. It's DT, no, TD, thread data. Or is it not a global variable? That makes no sense. Then how was it? How was this reading from it before? Oh my god, this is pissing me off. Okay, well I guess I'll just make a global variable then. Like what? I swear that was... I mean, when it goes into the populate verts, like that makes sense, but when it was rendering and looping through this, it was always going... maybe it was going off of VIDX, the global anyway, but... Okay, let's go through the arrows. What did I do here? What? Syntax error constant. Oh, this must already be a thing. Oh my god. Fuck. Fuck. Fine. good. Okay, okay, so I know that I need to, it's somewhere else that also is event max. Yeah. Okay. Fucking Christ, man. Unlock was point. Oh. Wait. Wait, what? Did I not, is it because of this at the yeah, that's what it is. Okay. Yeah. Just go. That's fine. Cannot convert. Oh yeah, so it's just more of that. Okay, let's just recompile. Okay, 6 errors. Running undeclared identifier. That's a global variable, man. That is a global variable. I guess I got rid of it, actually. I guess I got rid of it. Okay, I don't care. Just put it to true for now. Initializing cannot. Okay, so you're just being a dick. This is this. This is this. Okay. Okay. From unsigned long to thread events. Okay, but like sure, I guess. Just like cast it, bro. Okay, and that's what I was worried about. Okay, let's go through and test it. Let us test if we ever get into the rendering loop, because if I had to guess that we're just not signaling the event properly. So yeah, we never get into the rendering loop. That's what I thought. Okay. So I've got no clue how to do that. I don't know. I am calling set event for the RE event, which is the handle that we put into there. So I don't know. I don't know. Let me see this, if we ever get something back here. We do. Thread event render. Oh. I never actually called the function. Yeah, that would be it. Populate verts is what it's called. And it takes in T. Okay, well that's not working. And it's laggy as fuck as well. What now? I have to, step through it and figure out what's happening. That's what now. It's one of a few things. It's either we aren't writing into an actual V, which is possible. I mean, I set the pointer specifically before dispatching the threads. I set V to V here. Oh, fuck. Oh, shit. This is outside of here. Yeah. Yeah, that's outside of there. Yeah, that's not it though. That's not the bug. Yeah, I don't think that calling lock multiple times would cause a bug like that. So I'm not surprised. But we do set V to here. There are possible race conditions if yeah, I wonder if I'm calculating the B offset correctly, so let's test that next, what the B offsets are looking like. So that's 0. Okay, well that's massive, I feel like. While true, no. No, because we're only calling it when we set the event. Because it waits every time. I'm not debugging it properly. Oh yeah? You wanna enlighten me? Oh man. Okay. Okay, so let me think of the math here. So this is gonna be 32, 32, 16 by 24. So 24 by I think next channel is 6, so yeah, that is a large number actually. So I don't know if the B offset is correct, but I'm not debugging it properly. Interesting. Now, they should technically add up. So if we have, no, it's too small. It's the second time I hover over a variable before the code actually runs. Brother, I'm stepping through the code. I don't know. Like, I'm not in the fucking mood today, man. I'm just not. Okay. So, anyway. I assume that dividing cell size out is fine, but technically, oh no, because of channels, we aren't going to max channels, so it's not going to give us exactly the same amount, but yeah, so there we go. 1, 2, 3, 4 should give us exactly. It's not telling me, but yeah, 4 should give me exactly the correct amount, which is like 3 million. So that's what that was. So, oh right, it's not going to tell me the last one because the last one is the actual max. So I think I am actually calculating the B size and the B offset properly. I think I am. Oh, wait a second. It said stream source. Ah, hold on a second. Okay, well, a few things here. So this B offset is... I think that this is actually supposed to go up there. I don't know, I've never actually done this with a split up buffer like this in D3D. So I think offset in bytes might actually be what needs to be the thing. And this B offset would be times if it's in bytes, I think. Yeah. Yeah, it has to be. No. No. Okay, fine. Yeah, because this draw primitive start vertex probably. What am I trying to do? I'm trying to accumulate vertices from different threads into different parts of a draw buffer and draw them. That's what I'm trying to do. Yeah, I don't know. I had trouble with this syntax before. So honestly, just for our peace of mind, let me just do. It's also possible, I guess, that I don't know. I'm gonna step through this part next, but yeah, B offset is in vertices, so technically start vertex should always work for that. Yeah. Yeah, let me see here what the values are like. Okay, just hit it. Yeah, this honestly is taking a long time for it to yeah, so 3 makes sense. 6, yeah, so this is fine. Yeah, the fact that it takes so long to get there is really interesting. Because it should be like pretty fast to get into that. Let me make sure that we get out, I guess. We do get out. Okay. I'm sure it's something stupid that I missed. I do change curve buff, yeah I do. Yeah, you know, it's gotta be. I feel like it's gotta be the drawing. For whatever reason. What if I just like put 0 hard coded, I guess. And then let's just see it, I guess, what the VIDX is. 0. 0. Well, I'm not doing this properly. Okay, so it's all 0, which is very interesting. Actually, it might be 0 just because it hasn't gotten past the first render loop yet. It might just be only presenting the back buffer. So it might not be that, but we can check that another way. I set this for curve buff to 0. And I never touch the other one. Yeah, so when we switch, it should absolutely stay with the buffer. Should absolutely stay with the buffer. Hold on, let me step through that like a billion more times until we get like the amount of frames until it stops drawing. Because that'll be able to tell us threads access to the accumulator. They don't accumulate. Each thread they don't accumulate. They're all drawing to different parts of the same buffer. And so what I'm trying to get with the VIDX is yeah, but like it just keeps like hanging basically, which is, or no. So what's happening here is that we aren't getting through again. That's why we aren't hitting the breakpoint. And so that's probably the problem right there, is that we only go through once and then not again, which is the problem. But I don't know enough about Windows reset event and shit to know how to do it. I know that we get to here. And then I mean, obviously, I've been working on this, for a week. This works. We get back over here. Oh, fuck. Oh, fuck. Yeah, that's what it is. I was clearing out the handles, I think. Oh, wait, but the handles don't actually do anything. No, the handles don't even do anything. So that, yeah. That wouldn't even be it. Yeah, the thing is the whole thing, like, hangs. Is the annoying thing. Maybe I just reset event right after. I don't really know how that works. Yeah. Honestly, I'm kind of willing to just create thread again and not do this outer loop shit, and then just see if it's able to do it with this. Because it should be equivalent, is the thing. It should be equivalent. Okay. So now that's not even working. I don't think that the events would even matter right now. I wonder if I wonder if like we're just like causing like race conditions by touching the same parts of the buffer by accident or some shit like that. It's very possible that that's also the case. So I mean, I'm just gonna set it to one thread. Yeah, it's not hanging anymore, but it's also just like incredibly broken and laggy. This is so sucky. What should I see at this point? I should see what I should see a gelatinous cube of cell like I've been seeing from the beginning of the stream, but I wanted to make the threading more efficient, and so I went down this path of moving it into one buffer. Which apparently is sucky. Yeah, I wonder, I am logging. I mean, this is like the longest frame in existence, by the way. This is like insane. Insane. This is insane. So something is really, really, really badly broken. Oh, fuck. Did I? No, I didn't. No, I didn't. No, I didn't. No, yeah, it's got to be something that happens here with the this. Oh fuck! Wait a second. I never clear tdi.isDone. Okay. Well, it's like incredibly laggy, but that's because we're at one thread. And there is bugs happening because of the bounds, I think. But that's what the bug was. Okay. So I forgot to flip the flag that said that the thread was done. Which, you know, is a really stupid fucking thing to forget, but whatever. Now I've got 20 other bugs to fix, but at least that one's done. Okay, so yeah, it's just always something stupid. Yeah, so here I just have to do td is done equals, just make sure that it's false. I'm just gonna just do this now, and then I mean, I'm sure that there's a bug in here too, but okay. So set the event, reset the event. Hey Max. Yeah, honestly I didn't expect it to work, to be honest. I think the offsets are correct. I don't know why it's taking them so long to finish. Maybe it's a thing with from all the memes I watched. This is what computer science is supposed to look like. Yeah. Yeah, no, there's some issue with it where when using the new threading thing and not just like creating threads in the loop, the thread pool is like broken somehow. I don't really understand how the fucking create event and set event thing, you know, works. Honestly, what we should do is just like set these to like, what is it? Oh, no, just set these to auto reset events, because I obviously don't know how to do the resetting shit. And just like let Windows handle it, you know? Oh shit, hold on a second. We should never be actually setting the is done to false here, because we might get stuck in like some infinite loop shit. Yeah, I've got to step through the offsets to make sure that we're actually getting data into the buffer. But yeah, it looks like it just like gets stuck and it never finishes the loop, the thing. So we do get here, dude. We do get here. The thing is, we never get there again. That's the problem. Yeah, so we just never get to the, we never get in again. This shit is hung so bad that my whole computer is broken. Okay, go away. What each thread is executing. So what's happening is, right, so we get into here, we get this result, right, which translates to well, we can't actually see it, but it translates to the thing, and then we just never get through it again. But I mean, it's a good point. Like, maybe we never finish. Oh, fucking man. Wait a second. Is it possible? Is it possible that breaks out of this loop? In this case? There's no way that that's correct, right? This is scoped. This cannot happen, right? There's no way, right? Because that would explain a lot. That would explain a lot. There's no way, right? Okay. I had a bug like that once, though, where somehow, I mean, I think it was probably just like a different scope thing, but that would explain a lot. Oh shit! Wait. No, yeah. Oh my god, I'm so dumb. Okay. Okay, never mind. Breakpoint on return 0 line, easily make sure. Yeah, I could do that. I could do that. I don't think that, I think that it's just, the weird thing is that it never hits this again. Like, what? The whole thing hangs like crazy. Yeah, so I thought that I closed the handle. Okay, so let's just see. Yeah, that's what I thought. Damn, dude. I don't understand why we don't have like fucking p-thread, dude. P-thread would be so tight right now. When I pause the execution and check the call stack. I don't know how to do that on Visual Studio. You're talking to a Vim guy, bro. I'm brain rotted, unfortunately. Oh wait! Oh my god! 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 Don't mind me. Don't mind me. I'm stupid, bro. I'm stupid. I'm stupid. I'm stupid. I'm stupid. Wait, that's not the bug though? I mean, that's definitely the bug. Or at least a part of the bug. I was waiting for objects that were never going to be done. But now why doesn't it work still though? Hello? Okay, so we're done lagging now. Okay, but like bro? Okay, but I did it all correctly. Fucking do the thing, bro. Dude. Okay. Maybe we just go back to this. Okay. Okay. Now that's not working either. So our threads are finishing, dude. Our threads are finishing now. Everything is taking really long, which is concerning, to be honest, but whatever. So our threads are finishing. At least I think so. Wait, hold on. Do we never get frame finished? We do. Each thread is taking forever, though. Okay, but then threads are finishing without without finishing a frame. Maybe, yeah, I don't know what this reset event thing does. Like, I've read the documentation and it did not enlighten me whatsoever. It did not. I really want to see Yeah, it's kind of pointless to just like see, hey, did we get a thing back? You know, it's kind of like pointless. Um, Thanks, Lane. I feel like currently it's unworking right now. It resets the state of the signal. Okay. Thread synchronization works using signals? Basically, yeah. But, you know, in this case, I don't really know, like, I should just set the signal and then reset it. I don't reset it at the end because then it risks, you know, looping. Like in this case, I'm supposed to set the event. Like what like don't I have to wait to reset it? Right? I need to know if all the threads got the signal. Does that make sense? Like, I think. Like, because what I think is happening is that it goes through here and then it goes through again. Read document again? Sure. Sure. Let's go set events. Okay. Let's read it again. The state of an auto reset event object remains signaled until a single waiting thread is released. Okay, so we don't want an auto reset event object. Any number of waiting threads or threads that subsequently begin wait operations for the specified event object by calling one of the wait functions can be released while the object state is signaled. Okay, yeah, I understand all of this. This completely makes sense to me. It completely makes sense to me. However, in my case, I feel like I set the event, I send them on the mission. And they go, and they go. But this if I do this, right? If I do this, then they never get in. So I have to wait to reset it. I have to wait to reset the signal for the event. And so it makes sense, right, to just do it here, right? But the problem is that if one gets done before the other, it's going to still see the signal, and it's going to be like, oh yeah, time to go, and it's going to fucking do it again. So this is not, no. This cannot work. It can't work, bro. Unless I have events for each one, which we could do. We could just straight up have events for each thread. Is that stupid? Okay, hold on. I'm explain why I'm using events in the first place. Okay, so I have 3 different threaded things, right? That I want the thread pool to do in an order, right? But they don't happen sequentially, right? They happen at different points, right? So this is Sobel convolution. This is a second Sobel operation. And then I need it to do the render loop, right? So this was the way I Googled, and it said, hey, make an event for each one of them, and then just, signal which one to do, right? And so that made sense to me. So the thing that's happening, right, is I'm just testing it with the render loop right now. So I send it the render loop signal, and then I just check when they're all done, and then it's done, right? But yeah, so what we could do, this is extremely suspicious, okay? But we could just go in here, okay? And we just set it to, okay, hear me out. Instead of setting it here, we do that, okay? And now all we do is we wait until they're all not done. Yeah, so if done is 0, then we gotta reset the event because they all got going. My logic is sound there. I just think it's so fucking awful. Okay, but it still doesn't work. Oh wait, it does work. Wait, what the fuck? Dude, am I like a genius or something? Okay, but it looks like shit and it's so slow and it sucks. Oh my god, it sucks and it's so slow and it sucks. Bro. This is like the slowest thing in existence. Check time and output? Yeah, I will in a sec. I think it's just the thread shit, bro. Alright. You had your time, buddy. Go away. Go away. Shut the fuck up so that I can read it, man. Oh my god. Now it's just gonna give me a bunch of nonsense. Oh my god. You fucking asshole. Why do we not have any timers? Wait, what? Why is reintegration 0.93? That was not that nearly that expensive before. 0.93? Really? Really? That was like... Wait, why? It's the same thing as it was before, man. We literally didn't change anything. What? Okay, here's something. Here's something. Let's just never set the event and let's just compare the time. Let's just compare the time without rendering at all. Because that'll tell us. That'll tell us. Okay, we got it to render, but it's just incredibly fucking slow compared to what we had before. So let's just see. Okay, well, of course we're just gonna have a bunch of render loop finish. Yeah. I'm. What? 0.94. What? Why? I didn't change that though. I didn't change anything in the reintegration step. You know what it might be actually? It might be our... How about this? Let's try to get rid of the timers. Well, but then we can't profile it. With the simple git, yeah. Yeah. Yeah, that's so weird though that's the reintegration step. The reintegration step was fine before. Okay, let's get rid of the frame finish shit while we're doing this because that's just gonna give us a bunch of nothing. It's also possible, I guess, that like... Why is it so hard to close the program now? Okay, so I forgot to get rid of the render loop finish, which is the entire thing. Okay, here's my next trick. We're gonna get rid of whatever that fucking printout is, and I'm just going to never... Yeah, get rid of it. Get fucking rid of that. Okay. Okay. Now hear me out. Hear me out. Maybe we're just never getting back into the loop because we aren't showing it again. Oh right, because of this. This is never gonna be true. Okay, like, listen to me. We're not rendering right now. I'm going if true. Two of them are workers and one is them is to render the screen. Basically, yeah. The main thread isn't anything special though. It's literally just... Yeah, dude, why is the reintegration step so... This was like 0.06 before. And we didn't touch it. We literally did not touch it. I'm almost wondering like if we should... Like, do I think it's the mem copy? Or like we didn't even touch anything here. This was working not too long ago. So let me see. No, this is still insanely large. Is the timer correct? That's what I was wondering, right? I mean, maybe the timer's somehow wrong, but like... But for it to be consistently wrong would be pretty insane, for sure. I mean, it probably isn't wrong, considering that that like it's obvious that we're like lagging the fuck out. So I'm trying to prove it by commenting stuff out. Okay, there we go. So it is correct. It is absolutely correct. It is just... Okay, so it's this compute DPMU line. 100%. 100%. Yes, this compute DPMU line. It's this one line. Wait, what? The fuck are you talking about? I feel like that this can't be right. What? Okay. This function is taking up 0.7 seconds, and it's literally just finding the difference between two numbers. I didn't mess with the pause array, right? Isn't it supposed to be ZYX? Or no? Maybe not. No. How is that the problem, though? There is a bug here somewhere, I guess. It should never be border Taurus, because that's locked in a const. Okay, I just did it. It's the value of channels. Channels is hardcore set to 3. The value of grid size. I mean, the thing is, we loop over grid size so many times that it's definitely not a problem. It's a 32 by 24 by 32. And also, this function was completely fine earlier today. Mr. Robbie can attest to this being 0.06 earlier today. And now this one line is 0.7 seconds. Which is just absolutely insane. I suspect some sort of like stack corruption or some shit, because there's just no way. There's just no way. Oh right, I forgot to do this. Somehow that came undone, so we weren't looping. But yeah, I mean this is staying ridiculous. Like what else did I touch that could have resulted in that. I mean, I really only touched TD. And this is the timer stuff. I didn't even touch anything in that file. It's the craziest thing. Like, here we're doing the timer thing, and back here it was fine. Shut up, shut up, shut up, shut up. Have I touched this fabzev function? I mean, it's not my function. It's, you know, it's in a library. Dude, like, shut up, please. I mean, it's possible that the timer is wrong, to be honest. I think the timer might be wrong. Like, what if we just, like, get rid of... Okay, here's the real test. Just get rid of create thread. Get rid of create thread and then just, like, don't do anything. This will be the real test. It's like... Like... I mean, it's possible that the timer is wrong for whatever reason. I've, like, no clue how it would be wrong. How many cores does my actual CPU have? Four. But I'm not even, like, this is with no threads, right? It's with no threads, so... That's crazy. That's crazy. That's crazy. I feel like it's got to be something stupid. There has to be, like, something so dumb that we did going on here. It has to be something so stupid that's happening here. Maybe something that just didn't, that we, like, stopped initializing to 0 at some point by accident, and now it's like a problem. Let's try something. Let's just put it over here. Try to grab the whole thing. Yeah, I mean, yeah, I don't think that the timer is the problem, because it's all it is all going back to here. Okay, let's try this. Let's try getting rid of fabzev. Okay, that's a bunch of the time off of it. But it's still... Okay, let's try this. Let's try just doing the channels on the outside and this on the inside. Dude, I mean, I don't know. I don't know. Yeah, I know. I'm just coping, I guess. Oh, no. The off table wouldn't matter because the off table doesn't even touch this. But I could try calicking this. I don't think that that's it. But, you know. Honestly, I'm considering just running back everything I did since then just to try and figure it out because I feel like otherwise I'm just never going to figure it out. Last ditch effort, let's just like get rid of that. Get rid of the whole like render loop. In fact, just like straight up comment it all out. Oh man. Yeah. I don't know. Something touched it. Something touched it. At some point, something we did fucking touched it. Try commenting out the outer loop and check the timestamp. You're talking about like inside of here? Or inside of here? Like here, this is the part that has it, the problem. Well, that's not actually all the problem. It's kind of more than that, apparently. It's not that either, I guess. Yeah, it doesn't seem to be that either. Like, what is the... I'm just trying to figure out what... Yeah, we can add a timer too. But I am leaning towards just undoing everything, to be honest. I know that sounds sucky, but I really do not know don't know what I did, so somewhere I broke something, and I feel like the only way I'm gonna figure out is by... Wait, what? I wish that you could go back faster than that. Oh. Oh, fuck. Oh, no, that wasn't there. I thought for a sec that there was... that it was calling itself recursively for a second, but no. It's not that easy. It's not that easy. Why is it not printing out? Oh, because I didn't... Oh, man. Yeah, it's the exact same thing. No, that's before the mem copy. So you know what? Let's see what what is row size? 21. Is it really 21? It's 1 times 2 plus 1, so 3, 9. Yeah, so it is. That's correct. That's 0, 0, 0. Okay. So that's fine. The problem with shit like this is it's like what see a lot of zeros in the offset table, to be honest. It definitely gets initialized, but I don't see any values in it. I do initialize it there. Is that a hardware breakpoint, like a watch? Wait, what? Wait, hold on a second. What? Wait. Hold on a second. Maybe I just try a DD of, well, no, not a watch. I don't know how to do that then. Yeah, but I mean, then, like, even if this is the case, like, it's like, this, like, yeah, I don't think that this is the problem, because it was working fine before is the thing. So, yeah, it's definitely not. I don't know. I feel like I'm spending so much time debugging this when I could literally just go back and then just like reprogram this shit with like what I learned, to be honest. I feel like that's what I'm gonna do at this point. I know like that for most people that's like, you know, stupid or whatever, but I'm literally just going to back up my files and run it back. Like, I Google about it later. All right. Yeah, I've never done that. But yeah, I'm just going to copy things and then just run it back, because, you know, I don't know. This is kind of how I deal with stuff like this, because yeah, sure, maybe I'll like figure it out like in a few hours, but it's like it's gonna take me longer than if I just like legit just go back to how it was before and then you know, I'll figure it out that way when I redo it. So I'll probably be like, you know, slapping myself once I figure it out, but you know, it's not like it was for nothing, because I did figure out how to do this stuff for next time. Well, not for next time, but when I redo it, now I know how to do the events thing or whatever, you know. This was a lot of fun. Well, this was a lot of fun. I should do this again. Yeah. I think that this is, yeah, this is back to where it was when we did the timers. Yeah, I'm just gonna go back to when we did the timers, because that's, I need local git. Yeah, I don't know how to do that on this machine though, is the thing. Yeah, that would be pretty awesome. Okay, well, this is timers. Yeah, so the thread events can stay. I doubt that the enum for thread events was the... yeah, let's just get rid of it. And then here, literally none of this. Back here it worked, so... Okay, well that's literally everything back to where it was. I'm pretty sure that that's everything, so. Alright. If it still doesn't render, then that's... Alright, peace out. Peace out, Andre. You know what? You know what? You know what's crazy, actually? You know what would be crazy? Alright, well... Okay, well, it's a good thing that that I just backed up all those files. It's a really good thing. Yeah. That's exactly what it was. That's exactly what it was. So. Yeah, so let's just rename these real quick. I don't care. I do not care. Wait, did I copy? Yeah, I did do main. Okay, that's good. Oh shit, F2? Oh, that's clutch. That is clutch. So that's so clutch. Yeah, that does piss me off though. That pisses me off so bad. There's kind of like a relief to it though. There is like a relief to it, for sure. I don't understand why there's no... Yeah, whatever. Am I Jewish? Why? Why? Yes to all. Okay. So that should put us... Okay, yeah, so this is where we had everything commented out. Unreferenced local variable. Bro, I'm fucking... Unreferenced local variable? Huh? What does that mean? Oh, that isn't the problem. It's a linking issue. Error unresolved symbol. iDirect 3D Cellverts 2. Oh, render.h isn't updated? No, it is. The coding of physics engine? Cool. That's sick. Yeah, maybe I just like exit out and reopen the project. Surely. Okay, that's fine now. Okay, so we don't render anything, but that's to be expected because we commented everything out. This is still more expensive than it was before, but I'm not sure. I'm not sure what we have inside of there, so yeah, we have this extra timer in there. Is that a game or what? Is that a game or what? It's a cellular simulation. Dude, what a bummer, man. Okay, by the way, this is supposed to go inside. And the reason why is because of some cache bullshit, I think. Yeah, exactly. See, I know what I'm doing. Wait, but it's still slower for whatever reason. Oh, wait, hold on a second. This is, we got rid of Fabs F. Which I don't know how that would make it faster, but... Okay, bro. It went from 0.08 to 0.06. So... I don't know. But... At this point... I think we say let it rock. I'm just going to... You know... Put this back... to where it was and try this again. See, so much so much power. I don't know if this is power. This is more like weakness. You did a lot of nested loops, I think. Yes. I think it's the only way to calculate it, but you know. But maybe I'm wrong. Give it a shot. Let me know. Okay, I mean, okay, well that's... we are out of bounds. Oh. Yeah, because I don't unlock the buffer. Okay. What is this program for? Myself. I probably didn't put something back here. No, I did. I did do this. Dude, like, this is so crazy. Done equals 0, we reset the event. Did I set this up again to go correctly? This is set up like how it was before. I'm probably not remembering that I commented something out while I was fixing that, and now it's not doing it properly. Did I change everything back here? Thread event max? Yeah. Yeah. Yeah, that sounds about right. Windows XP, that is crazy, man. Yeah, it is. It is crazy, man. Yeah. Oh, brother. Okay, let's throw it into debug mode and see if we're drawing anything, or if we're supposed to be drawing anything. Oh, if true. Oh my god. Oh my god. I forgot to set that back. That's what I forgot to do. Okay. Okay. Okay, well. Okay, so obviously the offsets are incorrect because this, this blue on the sides is just a bunch of bullshit. Yeah. Also, it's slow as shit, which sucks. If I had to guess, it's reading past what it's supposed to be reading, right? So yeah. Yeah, I don't think you wanna do the offset and bytes thing. I think that you just wanna do the B offset here. I think that's what you want to do. But we're not at the right index. How many hours a day? I don't know, bro. I would keep track. Okay, I mean, like, okay, here's what we should try. I'm just gonna try it with one thread, because if the artifacts keep showing up with one thread, then I don't know. How much it took to make this renderer, and also I really recommend doing it with OpenGL. I have an entire game engine I wrote in OpenGL, but I wanted to do this in DirectX. Yeah, so this artifact with the green channel is still happening, which is really annoying. Even with one thread, which is very uncool for it to do that. It's definitely not iterating this inside here, right? Oh shit, maybe it is. Oh shit, maybe it is. Yeah, maybe let's switch to, I mean, you know, cache way, whatever, who the fuck cares way. We can try it on the outside. I'm worrying about the contiguousness of the data or whatever. Okay, did I break this by doing that? I did break it by doing that. What am I talking about? Yeah, I fucking did. You gotta move this back down here. Okay, maybe I don't know how fucking loops work or what. Do I live in New York? I used to. Oh my god. Oh, that's a new one. That's the first time that's happened. That wasn't even like a, nothing even happened there. Like there wasn't it didn't hang, it just straight up said good night, you know? That was crazy. Why am I at this resolution? Oh shit. Nah, we're all good, bro. We gotta get out of this resolution, brother. What resolution am I usually at? Okay, it's definitely not this one, but I think it's this. Yes, it is. Okay. Okay, so we're going to not do whatever I just fucking did, and Windows encountered a serious error. You don't say. You don't say. Okay, so whatever I just did here is cursed as hell. Yeah, you know, I think that this probably isn't the bug anyway, so we should probably just put it back. Let's just put it back, man. Put that shit back where it came from, or so help me. So help me. So help. You know? No, yeah, it's definitely not that, because that was working threaded anyway. So what could the problem be? B size? Do you think it's B size? No, but it's happening with one thread anyway. That shit is happening with one thread anyway. So what? What the fuck? VIDX for curbuff is getting set to 0. But that's the one that we're the one that we're doing. Okay, here's the ultimate test, okay? let's just, instead of creating threads in a pool, let's just straight up try to do it like that, and then just do this again, just so that we can make sure that this isn't being stupid, that it's not that. Okay, so that's what we're gonna do. Okay. Oh. The RI is 0.04. That's crazy. That's crazy. That is crazy. That is crazy. That is so crazy. Why are we not fucking drawing anything? I don't know. Why are we not drawing anything? Today has been so cursed, man. Just so fucking cursed. Try 0 to the VIDX, I guess. Like, oh yeah, that's probably what it is. It's we never set the is done flag. TDI.isDone equals false. Yeah, my bad. Okay. Okay, so this, it's also not working. Does it have the same artifacts? It does, doesn't it? Yeah, it does. It has the same artifacts. Which means that it's not actually inside of our threading, but probably in how we're doing this. Oh, by the way, we only can do this with one thread. Oh, we are with one thread. Yeah, apparently, I mean, switching to one buffer didn't work, I guess. You know what else I did, though? I did switch to 30 from 36 to 22, so I could try this. But I do kind of doubt that that's... Why does it look so bad? Maybe I did also switch this from channels to max channels, but I don't think that should break everything like it does. Yeah, the thing is, none of this... all of this stuff is guaranteed to always work. So... oh, yeah, I don't know. I may have, like, touched something here while we were doing all of that shit. Like, I changed this way back when. This is not supposed to be that, I guess. But that doesn't matter. Let me see what the VIDX is, I guess. Oh, it's not going to tell me because... okay, but like... I would... okay. Wait, why is it always 0? Maybe because it literally is 0. Wait, why is it not? B offset is 0, yeah. Yeah, so the right one is going through. God, it's gonna be the dumbest thing once I figure it out. It's gonna be the dumbest fucking thing ever once I figure out what this bug is. me try mem setting this. I'm not sure. Might as well try it. Also, let's try getting rid of this and just doing Conway. Shut up. What is the problem? What? Oh. I don't know. I had mem set for V earlier. I see. Okay, so the problem is not in our rendering, but it's actually has to be here. Let me try let's try doing a copy into back and also mem setting back to 0. I have a feeling we messed something up when we were trying to fix things. Oh, I didn't enable any of it, did I? It's so slow because it's in debug mode. Okay, let's the mem setting is definitely going to take a toll on it. I find it so bizarre how earlier today it was so volatile, and now explosion simulator, yeah, it's not doing what it was earlier. It's not doing what it was earlier. And so I think maybe I look at this like side by side and see so that's incorrect. I mean, I doubt that Malik has anything to do with it, but whatever. Sure. Yeah, that's fine. Nabla U. All of this is the same. That's literally the same. Literally the same. The roll is it the same? Yeah, it's exactly the same. And then this is the same as well, yeah. How long? About a week. Yeah, I mean, yeah, I mean, okay, now it's back to what this. Okay, whatever I did is correct. Whatever I did is correct. Okay. Okay, now that we have found our way back, we're gonna send it with 4 threads. That's what we're gonna do. We're gonna try to get the rendering working now. And to do that, I need to set this back to the B offset. Okay. Okay. Okay, so get rid of this. Get rid of the is done because it takes care of that internally. Put this back on. Bring back this set event. If they aren't done, we have to reset the event. Okay. We don't close the handle. Okay. We are not waiting for multiple objects because that doesn't work, obviously. And okay. I'm under no illusion that that's going to work. I'm probably forgetting something. Okay. Okay, now the question is, am I even 1% faster? Oh, is the flashing... Oh, I wonder if the flashing is due to it, the rendering, or... Okay. Is it faster? I have no clue. We're not gonna know until we check the... yeah, but the flashing... Yeah. There are some issues happening, for sure, with... I think it's maybe a bit faster. Oh yeah, but that's laggy. Yeah, it's when it's multiple channels. Like when you get red and blue in there, it gets super laggy. Still. I think, yeah, the flashing stuff is really frustrating. Yeah, like this. You see this this flashing on the right side? That has to be due to some issues with calculating the offset. VSync. I don't think it's VSync. Am I reading that correctly? Really? Is it that fast? Really? I mean, that was just one channel, so that's not that crazy. But the threads finishing that fast seems pretty good. But like, so I already went through and I checked the B size calculations and all of it was correct. Oh shit, hold on. This is 36. It shouldn't matter though. It shouldn't matter. 24 should definitely be enough. I don't think that it's possible for it to emit that many. Yeah, it's just not, yeah. It's not possible for it to emit that many. Where, yeah. Yeah, maybe we just won't see a lot of stuff until maybe we just won't see a lot of until we parallelize some of the other stuff inside. Oh shit. Yeah, well, that's yeah, we gotta figure out what's doing that. I gotta figure out what's doing that, man. Oh my god. Well, I mean, today was good. Does it get hot? I don't think it's even that it gets hot. I think it just touches some memory that's bad. Like it just goes out of bounds and then just like, oh shit, get out of here, sort of thing. I think because it's specifically when I force quit out. It's possible that it's something to do with the threads or something, that it can't kill the Sorry, my sister just got home. Yeah, I gotta figure out why that's happening. I think it has to do with the threads. But yeah. Okay. Send error report. Oh yeah, I just click off of it. Would that actually tell me anything? Whatever, dude. Anyway. I really wanted to just see if we're faster. That's all I want to see right now. That's all I want to see right now. So this is for 3 different channels. This one has 3 channels, or maybe it is 2. No, it is 3. Okay, we went out of bounds. This should never be going out of bounds. Oh. Okay, that does go out of bounds. Oh my god, no. Oh man, something is really bad. I fucked something up real bad. What is that? What is that? I'm gonna like break my computer at this rate. This is crazy, dude. The project situation is getting worse. Yeah, I don't know what is causing that. What is causing my computer to hard crash? But it's only when I don't think you can debug this. I pressed Shift F5 to stop debugging. Okay, let me see. Yeah, man, I'm like, bro, fucking shut up. Okay, so, okay, but we do go out of bounds. We do go out of bounds. Okay, we do go out of bounds. We know that for sure. This is times 36. How long before it happens again? Listen, it's not going to happen again because I'm going to solve it right now. And how I'm going to solve it is I'm just going to look here. Listen, max channels. I mean, it's got enough space in there, bro. It should have enough space in there, bro. You feel me? You feel me? Hold on. We gotta initialize it to 0. Wait. Okay. Oh yeah. Rob loves that one. Fucking Christ, bro. Listen. I don't know what to tell you. Okay, let's go. Let's make sure to go to max channels, okay? We put the VIDX to 0 always. Listen, so the only thing that could cause that, right, to go out of bounds is if VIDX is not sent to 0. Okay. So the janky thing that's happening here, right, is that I set the event here, which basically says to the threads, go do the fucking thing, right? And then down here, right, we check if none of them have finished, then we reset the event. Okay? If none of them have finished, because that means that they're doing it, right? The problem is, okay, if one of them gets done in here, somehow they just go through it real fucking fast, then this isn't true. We don't reset the event and then we infinite loop. Okay, but listen, if all of them are done, we also want to reset the event. So true. That's so true. Yeah. Okay. What is the problem? Syntax error? I don't do those. No, that's a warning. Yeah, where's the error, bro? Oh, syntax error. Oh, we can't do an initializer list. Oh, sorry, Rob. They don't allow us to do that, bro. They don't allow us to do that, bro. Alright, I gotta get out of here soon. Okay, this is 3 channels. Okay. Yeah, I think it. Okay, so here's what I think. I think that. Okay, here's what I think. I think that. Um, I think that our threads are going right in the background, right in that infinite loop, right, and then Windows like sends it a sig kill, right, but it just doesn't care because it's going in while true, right, and so Windows just gets really pissed off. It waits for a while and then it gets really pissed off and then it's like, fuck it, I'm turning off the computer right now. I think that that's what happens. So I think I need to figure out how to internally, you know, avoid that. But yeah, that's what I think is happening. I think that's what's happening. I think that because this happens and then we're waiting here, we're waiting for multiple objects for an infinite amount of time. I think it's just like, damn, these threads just don't fucking shut up. I'm turning it off, bro. So I think you need to try it on a virtual machine. Nah, that's fucking weak sauce, bro. That's weak sauce. What, you don't think I got multiple flash drives with Windows XP on it just in case? You're talking to the wrong guy, fella. Alright, listen. I gotta go eat some food. So, next, what I'm gonna do tonight, okay, is I'm going to fix whatever this problem is, okay? I gotta maybe do some Googling. I'm gonna Google, like, program crashing my computer multi-threading or some shit like that. Okay, but we can't see the output because our computer keeps crashing, but I think we are marginally faster than when we started today. I think maybe like we're like 5% faster than when we started, and it took like 7 hours. But listen, that's alright. That's alright because we're getting there, right? Yeah, with new big bug. But dude, listen, the possible gains here, you gotta think of the possible gains here because you gotta think after this, we're gonna have a thread event reintegrate. Okay? We're gonna parallelize the whole fucking shebang, bro. The whole thing's gonna be parallelized, you know? And we can probably get this down to 30 FPS. I'm convinced. Now, the fucked up thing that I want to do, so the reason why I'm still stuck on this project is because the next thing I want to do once I get this all parallelized is, you're going to hate this, but I want to render 4 of them at the same time. Yeah. Yeah. So, yeah. Now, not all of them are going to be doing the same thing, right? But it's different views of the same thing, right? And so you have the regular view, you're going to have the weighted neighbor sums, you have the growth on this quadrant, and then over here you have the kernels layered on top of each other. So that's what I'm going to do next. So that's what it's working towards, is it's going to have 4 quadrants, one with the simulation, one with the weighted neighbor sums, one with the growth, and one with the kernel, which is what I did in 2D as well. But doing it in 3D is going to be very, very cool and fun and sick. You don't think it will? It will work? You don't think it will work? Listen. I think I've done harder, man. I've done way harder. So, yeah. I've done way harder than this. But listen, for view with 30 FPS, the thing is, so we already have the data. We don't have to transform it at all. So it's literally just drawing. And drawing for us isn't ever the bottleneck. So I don't think it's even that big of a deal. You just saw the threads for one frame with our threads. It's not even, we already have the weighted neighbor sums and the growth in arrays. Like, all we would have to do is draw them. So right now the bottleneck is literally the reintegration step and the Sobel and this. Now, I'm not saying that, parallelizing those is going to be easy. No, it's going to be hard, but, it's going to be, I think it's going to be the same thing. My idea is it's going to be the same thing. Like, you're just going to divide this by threads, right? And then just, like, it gets its own quadrant, basically. But it's not that simple, right? Because then you have to have an offset that's computed for rows, right? And that's what we have previously, but we need to do that for each step, right? But yeah, I mean, it's whatever. The big thing is going to be doing this, like, once we get this down. Yeah, but I think with this I kind of want to just, like, I don't know, there's got to be a faster way to do this, but I don't know. All I did was I copied the Jax code for, like, NumPy or whatever. I just literally, like, copied what they do. But I think that we can approximate it faster and get to 30 FPS. We're not going to get to 30 FPS without, like, I'm thinking that instead of a full roll, what we could do is just straight up do a Gaussian blur instead of rolling the entire array. Because that's basically what this is doing. It's basically just moving around the entire field. And in 3D, that's fucking insanely expensive. And so what I'm thinking is, instead of that, we just take the end position of, our voxel, and then we just do a Gaussian blur around the mirror, right? But yeah, I don't know how to do that right now, though. So I'm gonna be back later, probably, or I just do some work on my own. All right, peace out. Okay, and if anybody tells you to fucking do SOA because it's gonna, make you a millionaire, don't listen to them, because it ain't all it's cracked up to be. All right, peace out.